Good morning, everyone. And I thank our guests already connected in the meeting. Sharp at 9:30, we will start. Thank you, Dr. Jaykumar Singh, sir, Dean R&D. Thank you, Dr. Sanjay Kumar Panda, sir, NIT Warangal, who is the inaugural guest. And thank you, Harikaran, sir, HOD of CSC. So we will sharply start at 9:30.
A very good morning to all dignitaries, guests, delegates, and participants. With a great joy and immense exultation, I feel privileged to extend my warm welcome to all presented here for practicing cloud computing with AWS, a short-term training program sponsored by All India Council for Technical Education AICTE. The program is planned to deliver key concept of cloud computing on AWS.
A very good morning to all dignitaries, guests,
And also
delegates,
plan
and participants.
to give
A great
hands-on
joy
using
in
various
this
case
presentation.
studies. The
I feel
objective of
privileged
this
to
program
extend my
include to
warm
know
welcome to
about
all present
AWS
here
global
for
infrastructure,
practicing cloud computing
formulate
with
solution plans
AWS,
about
a short-term
AWS
training
compute,
program
storage and network services.
sponsored by All India Council for
Also
Technical
understand the
Education
access
AICTE.
control and management
The
features
program
of
is planned to
AWS.
deliver key concept
Now
of
I
cloud
invite
computing
the
on
coordinator
very
of this
to all
program
dignitaries,
and guests
guests,
to
and
the today's
also
inauguration
plans to give
with a
hands-on
request to
using
address
various
the
case studies.
participants.
The
Firstly, I
objective
invite
of this program
the
include to
coordinator
know
of this
about
program,
AWS
Dr.
global
K.
infrastructure,
Amarendra,
formulate
Professor
solution
and Head of the
plans about
Department of CS and
AWS
IT,
compute,
KLEF,
storage and
to
network
address the
services.
participants.
Also understand the access control and management features of AWS. Now I invite
Amarendra garu, you need to unmute yourself.
Right, sir. Good morning, everyone, and sorry for the disturbance. Right. Let's start with the ACTE practicing cloud computing with AWS. First of all, I thank all the dignitaries who are connected for this inaugural session, and I thank all the participants who joined irrespective of their regular works in their esteemed institutes. And coming to this program, just to recollect, we applied for AICTE in the month of January 2020, and we got approval in August 2020. So we planned within a period of 2 months, but unfortunately, due to this pandemic, AICTE informed that you can conduct in online mode. Actually, we applied for offline. Later, they converted it into online mode. Again, we received 4 different types of mails from AICTE. So even we are unable to judge whether it can be done in online or offline. At last, they finalized that you can conduct in online mode, and they gave permission for us to conduct this event in 4 different phases. So the first phase is from today, 16th August to 21st August. And we also planned the second phase in 30th August and the third phase in September and fourth phase also in September. So the thing is, we expect that this 6 days program, short-term training program, which is sponsored by AICTE, will intact. There is a lot of thing to learn, and a lot of hands-on sessions are also available by the trainers. And as I informed you through mail, just I want to recollect that there will be 4 different sessions on every day, session 1, 2, 3, 4. So from 9 and again at 11, again at 2 o'clock and again at 3:30 p.m. Out of 4 sessions, daily, the first session, 9:15 to 10:45, we planned a guest lecture series by the experts in the industry and from international reputation, from IITs and from NITs. So regularly on every day, the first session will be a guest lecture series on the area of cloud computing. delivered by international experts. And the remaining 3 sessions, session 2, 3, and 4, will be delivered by our trainers. So we will introduce the trainers at 11 a.m. You will be having the first session of the trainers. 3 trainers from various international organizations are there to deliver you the practicing cloud computing with AWS topics. So you will have a full experienced lectures with hands-on training. We believe that after this STTP, since many organizations are autonomous who are connected in this, you can implement, you can design your curriculum with these areas, and you yourself and your students can acquire certifications on cloud computing with AWS. There are many certifications and you can search very easily on the AWS platform. So our wish is let us learn the topics in a clear way. Wherever we have any queries, you can easily resolve them, get hands-on experience, and in turn, you must be able to deliver to your students. And we need that all the participants are cloud certified. So I wish the sessions will be fruitful, and I thank all of you in connecting to this. Thank you, and thank you very much.
Next, I humbly invite Dr. P. Sai Kiran sir, Professor and Head of the Department of AIDS KLEF, to address the gathering.
Good morning, everyone. Thank you, Amrendra Garu, for inviting me for this inauguration of cloud computing through AWS. As cloud computing became part of our regular curriculum, previously it used to be like a specialization. But just like operating system and DBMS, cloud computing also became part of the core subject of CSC. We can't skip cloud computing just like OS and DBMS. Okay, it is part of our curriculum. So we can't imagine our life without cloud. Previously, we used to be in a situation where we can't imagine a day without internet. In the same way, we can't even imagine a day without cloud, because if you consider any and every aspect of internet, it is completely on the cloud, whether it may be Gmail or whether it may be our data which is being stored in Google or Microsoft or Outlook. So everything we are just storing and using the cloud directly or indirectly, knowingly or unknowingly. So just because the cloud computing became part of our life, so it is the high time for us to be equipped with cloud computing. We all know that we are using cloud computing, okay? But at the same time, let us be very frank. Let us be very frank that many of us does not understand about how to deploy a cloud, okay? How to configure a platform as a service or a software as a service. And this is a wonderful opportunity to learn about AWS, which is a major player in cloud computing. So by the end of this STTP, I'm sure everyone will be equipped with the practical knowledge about deploying a platform as a service or software as a service, and also the infrastructure as a service. So as the regular practice of KL University, a lot of emphasis will be given on practical approach rather than theoretical approach. Okay, rather than going theoretical, so more emphasis will be given on practical approach. And in the same way, the STTP is also planned in such a way that there will be more hands-on experience and hands-on training on using cloud with AWS. And I think there is also a WhatsApp group that has been created for all the members, where even the instructor will also be part of the WhatsApp group, so that you can ask the doubts not just during the sessions, but even after the sessions when you are practicing it and when you are having any doubts with it. So I wish all the participants to gain thorough knowledge on practical approach of cloud computing. And I congratulate Amarendra Garu for organizing this AWS STTP with the experts of industry and the academia. Thank you very much, sir.
Now, I'm glad to invite Mr. Harikiran Beg, sir, head of the Department of CSC KLEF, to address the participants.
A very good morning to one and all. It is indeed an immense pleasure to be part of this event, and it is also a great pleasure to be part of this entire program, the STTP on practicing cloud computing with AWS. Having gone through the content of this STTP, it really gives me a lot of encouragement, a lot of motivation to sit through all the sessions, because there is quite a bit of practical knowledge that one can gain through this event, through this entire STTP program. And I inquired with Amarendra Garu and the complete set of people who are hosting this program, and there is immense hands-on experience that one would gain through this program. So I request all the participants to actively participate, not just be there online, and don't just take it as another session, but ensure that you're practicing the whole event. I mean, you're practicing every little concept thoroughly, and make sure that you're able to gain all the necessary experience through this particular program. Uh, Trying to build applications on the cloud, and also trying to deploy a virtual private cloud. I think that gives us it's a very good starter for those people who are planning for their certifications on AWS cloud. So I think this program, I wish the program to help all the faculty members from various organizations, as well as faculty members from KL University, to give the right approach, the right direction for getting trained and practically strong on the AWS platform, and also be able to get certified on the AWS platform. I wish everyone, the entire team who's hosting the STTP, and I also wish all the audiences here present today from various corners of India, I wish you all the very best, and make sure that you're all learning. Thank you.
Now, I am happy to invite Dr. B.R. Raghuveer Garu, Dean Academics, KLEF, to address the participants.
Thank you. Am I audible?
Yes, Raghuveer.
Yeah.
Yes, Raghuveer.
Thank you. So, It's a pleasure to be a part of this inauguration, and I appreciate that the CSE and CSIT departments have come forward with practical application of cloud computing, wherein we will be developing applications and deploying it over the cloud. And this is one of the most important things that the faculty should be knowing, because these days students are aware of all these things, and faculty being the mentors for their projects. So they must be aware of how to use the cloud environment for developing applications and the operations related to it. So in this regard, this really useful for you. As Ari pointed out, like, make sure that you are not just a silent participant, rather actively participating and learning the principles as well as applying the same. That is the most important thing. So anyhow, in the near future, everything is going to be in the cloud only. So all of you should be aware of this and sensitize the students, be it the CSE or any other department. So some form or the other of the cloud has to be used in their projects for data management or data processing or the deployment of applications or whatever it is. So I wish all the best to CSE and CSIT departments and make the event successful. All the best.
Now I'm glad to invite Dr. B. Kumar Singh, Dean R&D, KLEF, to address the gathering.
Very good morning to all the participants. At the outset, I congratulate Dr. Amarendra for all his efforts put forward for application and getting the grant and successfully implementing the first phase of this training program, short-term training programs of AICT sponsored, practicing cloud computing with AWS. At the outset, I feel apt that practicing cloud computing has now become mandate for everyone. During the pandemic, we have seen that we were heavily dependent on the cloud services, and the junior faculty would definitely have faced some issues, and this would be the right platform for practicing or answering those issues, sitting with the experts, peer members of this area. So I feel that it is very apt in the present conditions or situations. Having said this, I'm also happy to note that the number of participants, 104 participants, have already registered for this phase 1, and around 52 institutions, faculty belonging to 52 institutions are participating in this phase 1 of the training program. I'm very happy to note this, and I wish all the participants will be having a happy learning during this course of 6 days, which would be a very hands-on program and a program which is intense with learning modules. I wish the coordinators all the best in implementing this program successfully. Thank you very much for giving me this opportunity.
Thank you, sir. I'm glad to invite Dr. K. Subbarao. Now I'm glad to invite Dr. K. Subbarao, Principal, College of Engineering, KLE, to address the participant.
Yeah, very good morning to one and all. I welcome all of you for this AICT sponsored short-term training program on practicing cloud computing with AWS. First of all, I would like to congratulate the coordinator, Dr. Amarendra, and his team. The help given by Head of the Department of CSE, Harikiran, and Head of the Department of AIDS, Dr. Sai Kiran, and the entire team for making this event to happen. Well, this university from the beginning, we started in a small engineering college in 1980-81 academic year. Since then, the growth of this university in many directions, and today being NAC A++ accredited university with a category 1 status by MHRD and 41st overall ranking in NERF and QS iGauge diamond rating, Green and Clean Campus Award, Swachhata Ranking Award, and many more under its belt. The way this university organizes, the way this university conducts the program for the development of faculty and for the development of students, in turn for the development of the students, we give lot of importance for conducting such programs in this university. I thank the management, in specific our Honorable Chairman, Honorable President Sri Koner Satyanarayana Garu, for continuously encouraging the departments for conducting such events for the development of the students. The overall perspective of this university is to see that student develops, comes out of this university as an overall developed student. We give equal emphasis, equal importance, academics, skilling, personality development, research and innovation, and industry institute interaction and placements. For the past 16 years, continuously, we are achieving 100% placement in all the departments, and the efforts of the university, efforts of the departments, efforts of communication, soft skills department, industry relations placement department has made every department to achieve this event of successful 100% placement in every department. And I was informed by the coordinator and also the earlier speakers that lot of practical importance is going to be given in all these 4 phases. And I wish every participant to effectively make use of this wonderful program of phase 1, followed by the other 3 phases in various other slots. And I thank on behalf of the university all the eminent speakers from IITs, IIITs, NITs, and industry experts, foreign universities. And I thank all the eminent speakers for accepting and going to be a part of this particular program. And I wish this program a grand success. I thank the coordinator and other members for giving me an opportunity to be a part of this inaugural session. Thank you very much.
Thank you, sir. Now I invite Dr. Narsingha Rao Garu, Professor and RPAC, Department of CSC, KLEF, to address the gathering.
Good morning to all the participants and various dignitaries and organizers of this short-term training program. HOD CSC of the department, Mr. Harikan Bege Garu, and HOD CSIT, Dr. K. Amarendra Garu. Thankful to the organizers for initiating this kind of training programs, especially by the CSC and the IT department. Thank you, sir. Really, you've done a wonderful job, sir. Thank you very much. And all the participants who are attending this particular program must know that this is basically an AICTE sponsored program. Usually, AICTE programs are, well, well knowledgeable, and in fact, these training programs will enable the participants to get to know a lot using these kinds of technologies. That whatever we are, in fact, we are going to learn, we are going to develop different kinds of applications. So AICTE sponsored training programs will enable the faculty to get trained in different kinds of new domains and new technologies. Thereby, the learners will be able to develop different kinds of applications using these technologies. And in fact, I wanted to tell you, as an RPAC of the department, I wanted to tell you that STTP trainings, there are many training programs actually are being conducted by the different various colleges using through funding of AICTE actually. The motive behind these training programs is to enable the participants, the faculties, to get to know, to get a hands-on experience on various technologies, and thereby they will be in the motivation that they will be able to in turn they provide or make the students to learn these kind of technologies in the academic programs, especially during delivering the lectures and all that. So I definitely, I say that the participants will be able to use, once they learn the technology from this workshop, they will be able to deliver the goods to their own individual departments, individual programs to the students, basically, especially. Thereby, the student will be able to get to know different kinds of technologies, especially here in cloud computing with AWS. So various applications can be developed, by taking impart various these kinds of technologies to the students. And I request the participants to actively involve in learning the technologies using AWS for different various types of applications. Today, as an RPAC, I wanted to tell you here that different research, theses are coming on various cloud computing platforms. But actually, the student is not really been actually practical enough to implement a particular app using cloud computing. And in fact, this is a very demanding course, cloud computing with AWS, Amazon Web Services. It's really something very important. And I especially participants who are doing the PhD program, definitely by attending this particular short-term training program, they will be able to equip themselves with a different kind of with this technology, and probably they will be able to pursue their PhD program. Using this particular and develop different kinds of applications using this particular technology, especially with AWS. AWS is something which everyone should be able to know now. That this is a kind of a technology that every computer science graduate should be able to learn, and every faculty also should be able to learn, because tomorrow it is going to be everything is going to be cloud computing and with the edge computing. Okay, so if at all we want to develop any kind of a thing, any kind of a application in cloud or in edge computing, we have to be equipped with these kind of technology. Otherwise, we'll be lagging behind with other kinds of institutions and all that. So I really, request the participants to be active enough in learning this particular technology, especially from good resource persons, because the resource persons are all also coming from IITs and NITs. And it's a chance for the participants to get to know different kinds of, these kinds of technologies by attending these kind of workshops also. So I wish this program will enable the participants to learn this technology and apply this technology for developing different kinds of applications. I wish this particular training program a grand success. And I also wish all the participants who are attending this particular program will get to know the nooks and corner of this particular technology and develop different kinds of applications, cloud-based applications. And especially those who are pursuing the PhD program also, definitely this training program will enable them to equip with this AWS platform. Thereby, it will be helpful for them to pursue their PhD programs also. Thank you very much for being with us today. And I really thank the organizers for giving me a chance to speak before this erudite audience. Thank you very much.
Thank you, sir. Thank you, RPAC, Dr. M.R. Narsingarao, sir, for your gracious presence. Now, I would like to take the privilege of introducing our Honorable Vice Chancellor, sir, Dr. G. Parthasarathi Varma, sir, having a lot of research, academic and administrative at various institutes, especially the autonomous and the prestigious SR, where our Honorable Vice Chancellor, sir, served as a professor, a head of the department, and principal of SRKR Engineering. And he also worked in CBIT, the prestigious college in Telangana. And we are happy that we are able to see him as the Honorable Vice Chancellor. Right. Some echo is there, just we removed it. We are happy our sir, our guru, as the Honorable Vice Chancellor, sir, of this prestigious university. And I still remember that when we are applying this, I got a lot of guidance from VC sir, and I still believe that from his room itself, we applied for this AICTE program and we got approval. Now, I invite our Honorable Vice Chancellor, sir, Dr. G. Parthasarathi Varma, sir, to speak and to address the gathering.
Good morning to everyone at this place. It's a pleasure for me to address you on the occasion of the HTTP program sponsored by the AICT and cloud computing. And this is the right platform where you can upgrade your technologies, which is the opportunities given from the MHRD or AICT to upgrade your technology towards the latest trends and technologies out here. And I really appreciate the efforts made by the MHRD and AICT to train the faculty in the latest trends and technologies like this, and funding the Indian community in this process towards upgrading the things out there. Any teacher in this process, everyone has to upgrade their skill sets, otherwise you will be out of the game of this process. In this connection, everyone has to undergo the process of upgrading the skills in this process. Coming to the cloud computing here, nowadays, in the cloud is becoming everyone's coming into everyone's hand. Earlier, actually, the computers were invented, then laptops, then mobile phones, and everyone's dream is to connect to a server out there. Server is a costly affair. Connecting to a server, connecting to different firewalls there, routers there. That is actually when it is when you talk about a supercomputers earlier also, and that used to be very tough for any normal man at this place. The cloud made the things very simple. That's a server to bringing to everyone's hand, and through AWS or through Google Clouds or Microsoft Clouds, whatever. So access the clouds nowadays in the process, and cloud is making everyone's life very simple, and accessing any type of applications, any type of activities through maybe through your laptops, or maybe through systems, or maybe from the mobile phones at this place. In this connection, the cloud operations and the software building earlier, most of the software was converted from websites towards apps. Nowadays, everyone is looking after to converting their softwares to work in the cloud itself directly. All the softwares earlier used to install in our system. Now, if we buy the license of the cloud, actually in the software cloud license, it is very easy to take it up in the process. Not only that, the servers are maybe costlier earlier. Nowadays, through app, through server, through cloud, can easily take it up. Access this the cloud in this process. So nowadays the corona made everyone's to make online everything, and the supporting systems are there, and now everyone the future is only the cloud at this place, and a lot of applications to be developed on the cloud in this process. This particular area has a lot of opportunity in the future business in this process, and also everyone has to get into the training process and get upgraded skills towards the cloud, and that's going to give a lot of opportunity in future. And I thank everyone for giving me this opportunity. Thank you very much.
Thank you, sir. Thank you so much for your valuable information. It's a great pleasure for me to introduce our guest, Dr. Sanjay Kumar Panda Garu, to this gathering. Dr. Sanjay Kumar Panda is working in the Department of CSC at NIT Warangal, Telangana. He worked as the head of the department CSC at IIT DM Kurnool, Andhra Pradesh. He received PhD degree from IIT Dhanbad, Jharkhand, MTech degree from NIT Rourkela, Odisha. He has vast years of teaching and research experience. He received 20 plus awards from IEEE, ISTE, CSI, and others, which includes 2 silver medal awards for the best graduate and best postgraduate in CSC. IEEE senior member and ACM distinguished speaker. He has published 100 plus papers in reputed journals and conferences. He is a member of IEEE, life member of ISTE, and life member of CSI. His current research interests include cloud computing, artificial intelligence, machine learning, and Internet of Things. He delivered 90 plus invited talks and chaired sessions in many national and international conferences. He acted as a reviewer in many reputed journals of IEEE, ACM, elsewhere, and Springer, and many reputed conferences. He also served as a guest editor in many international journals. We are fortunate to have him for today's inaugural ceremony. On behalf of STTP team, I am requesting Dr. Sanjay Kumar Garu to address the gathering.
Thank you very much, madam, for giving my introduction. Respected President, Secretary, Vice President of KL deemed to be University, and Patton, Honorable Vice Chancellor, Honorable Chancellor, Honorable Registrar, Honorable Pro Vice Chancellor of KL deemed to be University, respected co-patons, Professor B. Hari Kumar, sir, from Head of the Department, Computer Science Engineering, Dr. S. Venkateswarlu, sir, Professor, Computer Science and Dean Placement and Progression, Professor B.R. Raghubir, Professor CSE and Dean Academics, Professor B. Srikant, Professor, Department of CSE, Professor P. Sai Kiran, sir, Professor and Head of the Department, AI and DS Department, Coordinator of this program, Professor K. Amarendra, Head of the Department, Department of Computer Science and Information Technology, KL deemed to be University, Deans, faculty members, staffs, participants, media persons, and ladies and gentlemen. So it is my proud privilege to be a part of this program, to give the highlights about this particular program and my experience towards the cloud computing. It is really a very nice program because I have seen a numerous of program as an expert in this particular field, which focuses on the various aspects of cloud computing without focusing a particular domain. But this short-term training program is focuses on one of the very popular cloud service provider, that is Amazon, and its internal details, how to deal with various problems or various, what is the internal architecture of Amazon Web Service and its implementations, in what way we can do the customization in Amazon Web Service. So I really congratulate all the faculty members and deans and the administrative staffs to put this proposal to the AICT, which focuses on a specific aspect of cloud computing. So more or less, people are now habituated with cloud computing, as said by various speakers. In day-to-day life also, we are using various cloud services like Gmail we are using, Facebook we are using, WhatsApp we are using. And the revenue of the cloud computing, if you see, it is increasing exponentially. Especially if you see this COVID situation, nowadays, if you ask someone about this online meeting platform to a small child, about Google Meet or WebEx platform or Microsoft Team or Zoom, all are habituated to this particular platform. But prior to this COVID situation, people are reluctant to use this particular technology. Not only cloud computing, as technology progresses, all the technologies are need to be integrated together to provide the solution. Previously, if you see in the last decade, all the technologies, if you see, you can see a border between two different technologies. Now you will see this border is blurred. Not only cloud computing, as you know that nowadays artificial intelligence, machine learning, Internet of Things, quantum computing, blockchain, all the technologies need to be integrated to provide the solution which will focus to our real life. So we have to see that how we can develop a very small product, because if we cannot do a very big thing, let us do a small thing in a great way, said by some of the pioneer researcher also, or some philosophies in the philosophy, right? So if you see, if you can do design a small applications which can helpful to our real society, a real life, we can use this particular application, that will be really helpful. With respect to each and every domain, we have several challenges. Let us consider the transportation system. Nowadays, you can see if you want to visit to one place to another place, we are dependent on various applications that is installed in our mobile. Let it be where is my train, or let it be we want to know the density of a particular place, or we want to know the traffic signal or traffic density of each and every place. So for each and everything, we want to use in a particular application which is hosted in our mobile. So earlier, if you see the definition starting from the computer to today's definition, as said by Professor Rajkumar Bhuiya, one of the pioneering research in this particular field, he told our cloud is nothing but the computer, which if you see in earlier context, people said the network is the computer. Earlier to that, people have said that there is some input element is there, something processing is to be done, something need to be produced. But the way we are progressing, we are saying our mobile is having everything. So with a single touch, we can reach to each and every place. Like here, you can see in this online platform from various parts of the country or abroad also, people are connected, and we can discuss some of the research topics. We can exchange our knowledge in order to build a good number of solutions to a particular problem. So you can see Amazon provides a lot of services. Like if you need computation, Amazon is providing Amazon EC2, that is Elastic Compute Cloud. And if you see Amazon Elastic Compute Cloud, you can create a free account if you want to use I want to see what is the internal functionality of Amazon Web Service. You can create an account in Amazon Web Service, and Amazon EC2 especially, it is going to give you 750 per hours. So you can use 750 hours per month up to 12 months. It is completely free. Not only that, Amazon provides several services. Like if you want storage, you can go for simple storage service S3. If you need cloud management, if you need serverless computing, various numerous services are provided by Amazon. With respect to student perspective, also I want to tell you one important point here. There is a quick lab which is also completely free, that is given to the user, where you can practice the services provided by Amazon as well as the Google Cloud. A numerous of experiments are available in the quick lab. People can utilize this experiment before going to the actual subscription of this particular service provider. So is said by Vice Chancellor that we are dependent on the supercomputer early days. Nowadays, Amazon also provide supercomputing facility through these cloud platforms. So based upon your requirement, you have to use these particular services. So you can see the main focus of this particular paradigm is that how we can utilize the resources properly. If you have a particular ICT components, the very first focus is that whether we are utilizing this component properly or not. But if you see the report of the last decade, only 5 to 10% of time the personal computers are busy. And if you see in the server context, the servers are busy for only 30 to 35%. We are spending a lot for purchasing the personal computers as well as the servers or the workstations. But if you see, the utilization is not above 50%. But due to this cloud computing, due to some other advanced paradigm, we have reached more than 50% of the utilizations. And we have to see that how we can optimally utilize the resources without expanding our infrastructure. So that is one of the very important role of the cloud computing in order to provide the services. Many small scale to medium scale industries are also heading towards the cloud. So you know that nowadays government also encourages our students and the faculty members to go for the startup companies. Many IITs, many abroad institutions are also have started their startup companies. The main goal of the startup company to provide some small products which will helpful to the society. So if you see this startup company, we don't have sufficient budget to purchase infrastructure. In that context, if you see, cloud computing will help you to provide the virtual infrastructure. So based upon your need, you can go for as many as number of resources. So you can see the latest hype cycle provided by Gartner, one of the research advisory firm. If you see, the public cloud computing and its adoption will take next 10 years. So we have next 10 years to work in this particular field to find a suitable solutions and develop different types of applications which we can host and which can also required for our particular society. Nowadays, you can see the Internet of Things as well as the cloud is integrated together in order to, these IoT devices are also generating a lot of data. So in order to retain this data, cloud is very much helpful. Not only these technology, a lot of technologies are also integrated with cloud to provide the unified solutions. So as said by our coordinator, Professor Amendra sir, it is a very nice program in which the first session is dedicated to the theoretical aspect, because we have to know the practical aspect as well, but for that we have to know what is the internal architecture, what are the different architectures available, what are the different services provided, what are the opportunities we have, what are the issues we have, challenges with respect to this particular platform. So we'll see some of the research challenges in the first session, and we'll see how to implement such research issues with Amazon Web Service. So I request all the participants to utilize this workshop, and not only in AWS, you can also go for Google Cloud. You can also go for the cloud provided by IBM. Okay, but the very popular paradigm, popular cloud platform is our Amazon Web Services. So we have to see that what are the internal details, what are the things we can customize in the cloud, and what are the services are provided by various cloud service provider, and how we can move our traditional infrastructure to the cloud infrastructure. Although these things are having a lot of issues and challenges, like as a computer science researcher or a faculty member or a student, you are aware of that security plays a very important role. That's why I told you, if you see the boundary between two different technology, now this boundary is completely blurred. So you have to see that how security policies can be enforced in the cloud. It is without impacting the computation of the cloud. So these are the various things you can learn in this particular workshop, along with the various functionality provided by Amazon Web Service. So I request all the participants to attend this program seriously and make utilize of it. And I also request the participant to form a group to collaborate each other. So a success of a particular workshop depends upon what kind of things we can produce in next 1 year. If you can write a small paper with the input of this particular workshop, that will be really the success of this particular workshop. So with this, I conclude my inaugural address. So thank you very much, everyone, for inviting me for giving this particular address. So thank you, everyone.
For your valuable input. For me, that I'm a vote of thanks for this meeting. I, on behalf of entire STTP team, first of all, spread my most sincere thanks to the Chief Guest, Dr. Sanjay Kumar Panda Garu, who gave this vital time from his busy schedule to grace this meeting, who honored this meeting with additional thoughts. I would like to thank our Honorable Vice Chancellor, Dr. GPS Sarathi Varma Garu, Principal, Dr. K. Subbarao Garu, Dean Academics, Dr. B.R. Raghuveer Garu, Dean R&D, Dr. B. Jayakumar Singh Garu, SC RPAC, Dr. Narsinga Rao Garu, HOD CSC, Mr. Harikiran Bege Sir, HOD AIDS, Dr. P. Sai Kiran Garu, HOD CS and IT, Dr. K. Amrita Garu, and last but not the least, our beloved participants for making this meeting a grand success. Once again, I thank one and all present here. Thank you. Dear participants, the training session will start at 11 a.m. sharply. All of you are requested to join in the same link.
Thank you, sir. Thank you everyone for connecting. And thank you very much for the guests. So you can leave the meeting and the participants can connect at 11 a.m. Thank you all.
Dear participants, again a warm welcome to you all. Now I'll start the second session. It's a great pleasure for me to introduce our resource person, Stephen Samuel, sir. Stephen, sir, has over 15 years of experience in the software industry, building and developing enterprise applications on dedicated servers as well as the cloud. His main areas are Java and related technologies and frameworks like Spring, full stack development with the Spring Boot and the Angular stack, main and MERN stack, as well as web services. As a trainer, he has worked as in-house trainer as well as independently for the past 10 years. Now I'm requesting the Stephen Samuel sir, please take over the session.
Good evening, everyone. I think I was on mute. So my name is Stephen Samuels, and I will be your instructor for this training program, practicing cloud computing with AWS. So uh, I hope my screen is visible and I am audible.
Yes, sir.
Great. If at any time the sound quality is bad or goes down, or I forget to share the screen, or the screen, disappears from your view, just let me know. Now, a couple of things. So I guess you'll know the schedule already. Our first session will be from 11 to 1, and with a 1 hour break for lunch, and then 1 hour 15 minutes after that with a 15-minute break. So we end at 4:45. Now, just a brief overview of what we will actually be covering. So our first session, let me try and make some space. I think this is covering up a lot of the screen. Okay. First, we will review the concepts of cloud computing and the value that it will actually provide to organizations. Give me a second. I somehow managed to get stuck with a pen over here. Let me get some real estate here. Right, that we'll manage with that. Okay, so in our first session, we're going to cover some fundamental cloud concepts for AWS. We'll review the concepts of cloud computing and the value it provides to organizations. So we have, after that, we'll actually delve into what exactly is AWS? What is AWS about? What is Amazon Web Services? We'll also look at how Amazon Web Services compares to other cloud providers because it's not the only player in the market. So an overview of all that. Then we'll review the organization of the AWS global infrastructure. Now, the idea, what makes Amazon Web Services so powerful is its scalability, its reliability, its flexibility. And a lot of this is possible because of the global infrastructure that it has in place. And then we'll go on to the tools and services that are provided in AWS. And we'll wrap today's session up with a discussion about identity access management in AWS, or IAM as it's called. That's to deal with permissions, roles, policies, etc. So we'll look into that. Now, this course is for developers. It's from a development perspective, so there'll be a lot of practicals that is there, a lot of demos. But our initial session today, I may as well tell you in advance that we will be going through an overview of the complete Amazon environment, if you want to say. So as faculties yourself, we all understand that it's necessary to have a thorough theoretical understanding and a conceptual foundation before we actually go in and start implementing any new technology. Or in this case, we are using Amazon Web Services. A lot of it is configuration, as a matter of fact. So we need to know how to delve deep into the UI actually that Amazon provides and understand how to actually bring it all together because there are a lot of moving parts. So to get a fix on these moving parts, we need to have a thorough understanding how AWS actually works. How are its services categorized? There's a lot of services, more than 100. Of course, we can't go through it all. So we'll go through the core services like EC2, for instance. And then we'll look at some of the advanced services. We'll discuss them like Lambda, okay, like AWS Lambda. And during the week, realistically, we'll be taking apart one service, either a core service or an extended service, and we'll be doing a deep dive into that. So that is a game plan for this training for the next 6 days. So we'll we'll cover the concepts of cloud computing, how the AWS global infrastructure is organized, a little bit about the economics of cloud computing as compared to when you're doing it on your own with dedicated servers, like how it used to be done traditionally. And then also the tools and services that AWS provides, and we look at identity and access management. Okay, so our first day is all about understanding cloud computing as regards the AWS, Amazon Web Services environment in particular. So, being faculties yourself, you'll understand that you need that thorough conceptual grounding before we can progress. So, I'm glad that I have a mature audience. But starting from day 2, we will be doing a deep dive and we learn how to configure and set up EC2 instances, how to use AWS Lambda and Route 53 and all the different services together. Okay. So the first thing we should do actually would be let us get you started. We need to set up an AWS account for you. So let's walk through the process of setting up an AWS account. If you have one already, great. So AWS actually gives us a free tier, and that's what we'll use. It's more than sufficient. It's for 1 year duration. So this will be very useful and actually very necessary for you as we go through each of the different courses within this training program. Each day, actually, you can consider a different course. All right. So now we'll create a personal AWS account. We'll then activate the account. And one more thing I would like to show you is how to configure a budget alert. And that's very important because there's too many people create accounts and then use some services unknowingly. Let me see. Last I remember is SMS is charged, but email is not, or on something on those lines. So before you get some unwarranted charges on your credit card or debit card, which is what you need to verify your your account, it's a nominal fee, like 2 rupees, don't worry. So before that happens, let us set up our account, activate it, and then configure a budget alert so that we can keep an eye on any changes that occur in account. Okay. So let us go to the AWS homepage. So just type in to your Google, you can just simply type in AWS create free account. It will give you something. Okay, so once you are over here, okay, I hope everyone can see my screen clearly. It'll take you to, actually, this is the home page. So don't click on create a free account right now. Click on create an AWS account. Okay, and then it will ask you to sign up, enter in your email and password. I've already done this, but I can walk you through part of the way. Right. Now, once you get through that initial page, you can see over here that they have a free tier, which you've probably heard about. It's always free, it never expires. And actually, in that sense, you have access to this for 12 months. I mean, these are the 3 different kinds of offers. Now simply select, for our purposes is fine. We can simply select personal. So I assume that most of you will just use a personal account to test AWS. So we need to enter in some additional information. So just go ahead and fill in whatever is needed. All right. One more thing, sometimes wherever there's any configuration involved, it's nice. I like to, even though we are communicating remotely, I really like this to be as close to a classroom experience as possible, even though we're not physically in the same location. So if you can follow along with me wherever there's any, if there's any, whatever configuration I'm doing on a screen, if you can do it at the same time, you can split your screen in half, for instance, and half you can view the WebEx meeting, my screen, that should be always visible, and half you can size your screen so you can use the browser, the AWS console, etc. For instance, if on Windows 10, if I go to Windows I and I go to display, then you have something multitasking over here. And keep the snap windows on. So in that way, you'll be able to resize your screen as you wish. So half of it can be my screen and half can be what you're working on, like the AWS console, for instance. Or another suggestion, everyone, if you have a smartphone with a decent size, big enough screen width, you can access the WebEx meeting from there. You don't have to do it right away. You can do it during the break on tomorrow. Because today we are actually laying down the theoretical foundations. So not many practicals today. So you could access the WebEx from your smartphone, and on your laptop, for instance, you can work alongside me. That'll be great. It'll save you time also later. If you come out of every session knowing 80% of what is covered, that's awesome. I'd be happy. So anyway, continuing on, we continue on. That's step 2. Now over here, they ask you for your billing information. Okay. Now your usage must be below the AWS free tier limits, remember. So you can enter in your credit or your debit card number, and as usual, expiration date, your cardholder's name. The CVV, of course, is at the back of your card. Enter in that, put in your PAN. Right now is best, otherwise it'll have to be done later. Just one thing about your cardholder's name. This is not the name on your card. Well, not always. Like for instance, it's a name on that is registered to your card. For instance, you might just have if you have 3 names, maybe the first 2, like I do. So it didn't take it the first time. So I had to put in my complete name as it was in my bank account, and then it verified, and then finally, okay, then I got access. So put in the correct cardholder name as in your, whether if it's a debit card, your bank account, name that's registered, or whatever name is registered to your card. So that would be about, anyway, so you carry on with this. It'll, okay. Then they'll give you an option that says that you have read and, you agree with the overall, actually, that with the overall customer agreement. So accept that. Then you'll get a link, a button actually, which will say create account and continue. All right. So now it's important, once again, I can't emphasize enough that AWS is a service that using the resources will cost you money. But there's several services which we are going to use that fall under what is called this free tier. So they allow us to try it out before we are actually charged for them. All right. So once you set everything up, there'll be some identification, and we'll need to confirm identity. So that will take a little time. You have the option of getting it via text message or via an SMS call. All right. So you can, I just chose to have it send me a text message. Then you enter in the numbers from your security check. Then again, AWS will send you a 4-digit code. You enter in that code and you can hit verify. I remember all this because I had to do it twice. Then your identity will be verified. Then you select a support plan, and that support plan you choose free tier. Fine. And after all that is done, it'll give you a congratulations screen. Then you can go ahead and sign into the console. It might send you a verification email as well. So you'll have two options. One is like this. You sign in as your root user. That is the user that was created with the email that you had given. Your IAM user is a user that you create after you actually log in as a root user. And that's advisable, especially in production environments, because the root user has unrestricted access. All right. Once you can log in, you'll have access to your AWS management console. Okay. So now we will be in, actually, once you log in the first time, you will come directly to your, actually, your home screen. All right. Now, be careful with this. I want you all to do this as soon as you have your account. So you go to services, which is just actually you just click the drop down, like you see my name over here. You come down to my billing dashboard, okay, and it'll open up this screen that you see in front of you. From here, I'm going to go to the left where it says budgets, and over there we will create a budget. As you can see, I have a budget right now in place. So click on that create budget and you'll see this over here, enable cost explorer. It hardly matters because sometimes once you create your budget, it'll be enabled anyway. And this is going to be a fixed cost. We're going to make a cost budget because we're just concerned with the overall cost. You can, so once you select that, click on next. Okay. You can name it as, name it anything you like. Monthly budget, for instance. Okay. And we're going to say that there's a budget amount. You can put anything. $2. You can put $1. Okay, we also need this as recurring. So let's take a look at this again. Set this up carefully so you don't have any run around with any charges appearing unexpectedly in your account statement. Set it as monthly is fine. Keep it as recurring. Your start month will automatically be selected to this month. The budget should be fixed. Your budgeted amount can be, keep it as 2 or keep it at $1. The filters you can, but these are normally needed for paid plans, hardly relevant for our free tier. Once that is done, you can click on next. Okay. And then once that is in place, it will show you your budgeted account. At today's exchange rate, it must come to around 150 rupees. Then we can add an alert. Okay, somebody asked me, you're in console page. Once you're in the console page, the first thing that we are going to do is to configure our, to set up our budget. None of us wants to have any unexpected charges appearing in a bank account because you need to give your debit or credit card information as to verify your identity. And Amazon will actually charge you 2 rupees to your account. You can see, check that. And after your identity is verified, that it will be replaced after about 3 to 5 days. Okay, a nominal charge. Now, once you get to your home page, click the drop down at the side of your name, and there's a My Billing dashboard. Okay, so click on that, and you will come to the page where I am. Once you're on that, on the left, you will see budgets. Okay, you will see budgets. Click on budgets, and you can just go through the steps to create a budget. Put in a budget of $2 or $1. And after all that is done, you'll get a configure alert kind of button. So you can click on that. We will set up an alert in case our budget is nearing the threshold. We will set up an alert over there. So that's what we are going. That is where we are right now. So you can see, in order to be notified of the state of your budget, we can create up to 5 different alerts based on our amount. Like we can create an alert to notify when we have reached 75% of our budgeted amount. So now we are going to configure our alert. All right. Now we will look at over here. You have an option. You have forecasted and actual costs. That's not forecasted is not necessary for us. It's very often used in production environments. For our purposes, it's fine. The default is 80%. You can put it to anything. You can put it to 50%. It's $1. So once it exceeds $1, my budgeted amount, for instance, my alert will be exceeded, and I will get an alert to my email. So I can enter in my email and anybody else's as well. So put in your email over here. That's all you have to do. So whenever it's nearing, for instance, in this case, 50% of my budgeted amount, which is $2, it'll come. So this is very necessary, you see, because there have been incidents in the past for many people where they have been charged because these are resources that in case we have access to resources, but if we use something that is not in the free tier, we could inadvertently incur a cost. This is to protect you from that. So I think then we should be Pratik, if you do not configure the budget and inadvertently you use a service which is actually a paid service, or if you go over, there are certain limits to the free tier which you'll need to read the agreement. There are limits to the services that you can use. Okay, so if you go over those limits, you will incur a cost. Now, the purpose of this budget and also this alert is that if you are nearing that threshold, actually you should not have any cost at all. But if inadvertently this is happening, you will immediately get an alert and then you can respond. So this is for your own protection. Okay, so once we have our email set up, we can just click next. We can review your alert. Fine. And then you can actually go ahead and create your budget. That's it. Okay. So now we've created a budget and it will show finally like how it's showing on my screen. My name I've given is AWS budget. Actual budget is $2. The amount so far is 0, etc. It will show on your budgets overview screen. Okay. This will let me know when I get within 50% of the budgeted amount during any single month. So you adjust it to whatever you want. Fine. We are only leveraging the free tier. So you can set it at $1 or $2, whatever. And have it alert you whenever it reaches whatever percentage you set of that specific target. So just to make sure, once again, that there are no unexpected charges on your AWS account. Kiran, it shouldn't be asking you for IAM role. You should be logging in as a root user. So the first screen that comes up after you finish setting up and it verifies your identity and all that, the login page, it should come up as you saw what I did. It should show you login as actually as the root user. You might have inadvertently clicked on IAM. So return back to the initial screen. Or you can just do a fresh, you can just Google Amazon AWS login from Google. You can click the link, login from there, but you need to choose root user because there are no, you have not logged in as yet as a root user. There are no identity access management related roles. Nothing has been created. That's much later. Okay, so try that. It's possible you might have inadvertently clicked on the IAM role. You must log in as a root user because this is your account. Okay, so now that we're done with that, take your time because you have to put in your credit or debit card information. You can always do it during the break also. What I would like to talk to you next is about traditional data centers. So we'll do a background of how AWS came into play. We need to understand something about cloud computing, the different kinds of deployment models that are in existence. For instance, what is cloud computing in the first place? Why do we need it? Also, so we're going to talk about how organizations leverage traditional data centers. And you understand traditional data centers because Cloud hasn't been around for that long, has it? Maybe a decade and a half, possibly 2. So we're specifically going to focus on organizations that have not yet shifted to the cloud. So just pretend that we have a fictional organization called Globomantics. And within Globomantics, there's a group that has decided they should launch a new social network for professionals as a new line of business for the organization. All right? It's like, let's take a sample scenario, a use case. Put ourselves in their shoes. Now, initially, they're focusing on the United States at launch. And if they're successful, they're looking to expand into Europe and Asia. Now, like most startups, they are currently working to secure funding for the initial infrastructure because, as we all know, it takes a good deal of money to build up the initial data center. Give me a second, please. I'm getting a call from Bitexo. Yes, Mahesh. Hello. Give me give me a minute or so because it seems there's an echo. I'll have to just see what I can do. So give me a couple of minutes. Maybe let me check. All right. Mr. Balaji, oh great, you're saying there's no echo. I've actually used the same setup for other trainings. I just switched. Could someone let me know, please, whether it's better, the sound? Please let me know.
Yes, sir. Yes, sir. Now it is clear.
It's clearer,
Yes,
better?
sir. Yes, sir.
Okay, great. Uh, Before I was using Zoom, I never had an issue, but maybe, who knows? Okay, great. So we know. All right, so where were we? Now, this is just like a sort of case study. Think about it. All right. All right. So let us begin to see how this might play out. So now suppose they were able to secure an initial round of funding. Since they're located in Nashville, Tennessee, they built a data center in Nashville. That's fine. It took 5 months from when they started to when. Okay, great, Kiran. You logged in with root user. I thought as much. Very good. So you're all getting set up because you'll need your account, believe me. Okay. There should be nothing to do with IAM at the moment. You must make sure that even if you're setting no actions, you don't need any actions at the moment. All right. Simply set your budget. Simply set your budget, $1 or $2, and that should be all. Don't go to actions or filters or anything of that because that would require other permissions which are not available right now. Fine. Okay. So once they were able to load their servers, then they know they needed several types of servers. They needed some web servers so they could serve their content out through their website. Then they needed some file servers so that they can store user uploads like profile pics. This is social network after all. Then they also needed a database server so that they could store user information like messages and who their friends are. Now they had a great launch in the United States and they felt that there is a lot of growth ahead. So they want to plan to move to Europe. Specifically, initially, they want to plan to move to Dublin. However, once the process starts, it's going to be another 6 to 7 months for them to be able to move into that new data center. Now, because of this, they need to go through that entire process and secure more funding, and they need to order some more servers. And this sounds familiar to you all, right? Of course. This is generally how it works in any organization. After 7 months, they're finally able to move in some servers in their data center in Dublin as well. Now they don't want to stop there. They also want to move into Asia, but now something unexpected happens. They take off as if they're like WhatsApp or Facebook or Instagram. They have tremendous growth in the United States and they need to expand their data center in Nashville. So they're able to go in and add some more servers. But once that demand happens, it takes them at least a month to order the servers, get them there, get them installed and configured. So during that time, several users were experiencing performance issues with their social network. So this is, how do you say, like a conundrum, like your website, your brand starts experiencing tremendous growth because you cannot keep up with that brand, you cannot respond. Scalability is the issue. So then finally, users will not tolerate those performance issues for long. The demand will taper off. The growth will also slow down or disappear entirely. Now, if it's going to take a month to order the servers and get them installed and configured, in the meantime, all those users will experience performance issues with their social network. Now, once all of that's in place, they're finally able to shift their attention to the data center in Asia. So that's on the right side of your screen. That's the data center in Singapore. It takes another month, 6 months to begin to get that in place and to order servers, and they then deploy their servers in Singapore. But something happens. Users that were interested in the platform in Singapore have already moved on to something else because you never came in at the opportune time. So they have all these servers and their data center sitting in Singapore being barely used, and they have put up a significant investment to get up and running. So let's pause a moment and let's take a look at what the scenario we just discussed. What have we learned from it? First of all, when looking at traditional data centers, it takes a large initial upfront investment. Organizations have to plan to either build a new data center or rent space within an existing data center. Next, forecasting demand is difficult. Even the best organizations struggle at this. Understanding how many users are going to latch onto a new solution, whether it's an external one like a social network or even an internal business application. Even if you develop an application you deploy over the web, unless it's mandated by the company, how many of your employees do you think will actually respond to it or accept it straight away? How many, really? Okay. Now, it's also slow to deploy new data centers and servers. So not everything can be ordered overnight, like via Amazon Prime, our shopping network. Not really. So there are times when it'll be very difficult to get up and running if you need to respond to a change in demand quickly. Then maintaining data centers is expensive. So with Globomantics, for every new data center that they spun up, they're going to need to add dedicated resources, dedicated individuals to maintain that server infrastructure at each of these data centers. And that is like a perennial cost, a cost that's ongoing. And next, you own all of the security and compliance burden with each of these data centers. So nobody wants to get hacked and nobody wants to be sued for being hacked. And if you're an organization owning these data centers, that entire responsibility, it rests on your shoulders to be sure you're following all the industry best practices. So now with that being said, let's look at some of the benefits of cloud computing. So now we see how it used to be, not used to be, still is. But to move from a traditional data center to the cloud, what benefits, why should we? Why should an organization do it? So what this is what we call a paradigm shift to cloud computing. Now, AWS in particular, because this course, we are doing some background on cloud computing in general, just to understand where we are coming from. But AWS itself calls out several key advantages. The first is you trade capital expense for variable expenses. So let me break that down for a minute with you. What that means is you don't have to have this large capital investment initially to build out a data center like we talked about in Globomantics. In this case, we get a variable expense, meaning that if we're using a server in the cloud, we simply pay for the amount of time that we are using it, and we can throw it away at any point. Now, later we'll talk about a little bit more about economics of the cloud, but that is the basic gist, and is a big advantage also. Now we get to benefit from the massive economies of scale. So this really factors in two different areas. One is just the cost of building out a data center and all the equipment involved. AWS buys things, as you know, on a large scale. So they're able to make sure they're getting the best price for those. So in addition, in the economy, we are actually talking about what? Economics, economies of scale. When we look at it like from a maintenance perspective, Amazon has determined already how to manage all these fleets of servers effectively at scale. And so these cost savings get passed down to us as consumers. Then we can stop guessing capacity. It's like trying to predict the stock market. So we talked with Globomantics about how difficult it can be to properly predict demand. Well, what if you just didn't have to? What if you could choose to have a system that could either grow or shrink on demand? So that is one of the paradigm changes that we get when we choose to shift to cloud computing. Next, we get to increase speed and agility. Okay, what do I mean? When we talked about Globomantics before, we mentioned that they were looking to find funding partners before they were able to go out and test their social network. That's not very agile. And organizations are into agile culture, DevOps and agile, as we all know. So ideally, what we want to do is to test out our hypothesis against real users and do it quickly. And one of the things that you can do with cloud computing is to try out new ideas and have minimal cost to do so. Next, you can stop spending money maintaining data centers. So, as I mentioned earlier with Globomantics, they were having to staff individuals at each of the data centers, and at each of the data centers, they would own that maintenance burden for as long as the data center was up and running. And so this allows you to shift away from that. And next, go global in minutes. So in the case of our fictitious Globomantics company, they had to wait 6 or 7 months to move to a new region in the world. Suppose they could simply send data over to Singapore or to Dublin at any point without having to build out new data centers. So they could literally do that within minutes instead of within months. Now, with these advantages, I want to focus now on a few key terms that you need to be familiar with as far as cloud computing and AWS in particular goes. The first of them is the concept of elasticity. This is what we talked about earlier when we talked about demand. It's the ability to acquire resources when you need them and then release them when you no longer need them. And in the cloud, you want to do this automatically. Now, AWS has several services available for us to do just this. And later we'll talk more about it. Now, the next concept I would like you all to understand is about reliability. Reliability, as you say, provide functionality for its users when it is needed. Now, Amazon's global infrastructure, that's why it's at the top of the heap, is there's nothing comes. Amazon's global infrastructure is excellent. And that's why its reliability is what Amazon AWS can provide. So now we talked about Globomantics. One of the things that we didn't actually cover within our data centers was things like failover. So what happens if one of the data centers actually goes down? One of the advantages of AWS is that it has a global infrastructure that is built with reliability in mind. So what we want our solution, whatever it is, to always be available to our users when they need it. So we can take advantage of this by building a solution on AWS. So we have the ability to lower the cost of trying out new ideas or business processes because we don't have to start from scratch. We don't have to build a data center or factory or employ staff to actually maintain those data centers. So let's take a new concept like blockchain. Instead of having to go out ourselves, hire individuals that have the expertise, that particular expertise, buy the hardware that we need, install it in a data center, and then start using it. In this case, we're simply able to tie into the resources that AWS has and use the services that they provide for us. Next, it reduces the time required to maintain infrastructure. So we begin to shift. Instead of simply spending time maintaining, we're able to spend times on things that actually add business value. Next, it does reduce the risk for the organization around security and compliance. And this is a big one. Now, we do have to, don't let anyone tell you that you don't have to think about security when you move to the cloud. You certainly do. There's also an AWS shared responsibility model. So what it actually means is we understand what is our responsibility and what is AWS's responsibility when it comes to security and compliance. Then finally, it provides access to emerging technologies, and like as we mentioned, blockchain, without having to spend a ton of money to ramp up on that new technology. Now that we've gone through and discussed benefits of using cloud computing, let's take a minute and talk about the different types of cloud computing. Now, before we dive too deep into that, let's discuss a definition for cloud computing as a whole. AWS says that cloud computing is the on-demand delivery of compute power, database storage, applications, and other IT resources through a cloud services platform via the internet with pay-as-you-go pricing, and that pay-as-you-go pricing is critical as we discussed before. So let's look at some different models of how we use cloud computing. Let's imagine for a moment that we have like a spectrum. If you can call this a spectrum, it's actually just barely two colors. And on the spectrum, on one end, we have absolute control. But on the other end, we have minimum maintenance where things just run without us having to think about it. Let's imagine three different points on this spectrum. First of all, on the far left, with maximum control, we have infrastructure as a service, or as we commonly know it as IaaS, infrastructure as a service. This is where we run servers in the cloud, virtual servers that are very similar to how we would run servers in our own data center, meaning we have full access to those servers. We can change the OSs running on them. We can completely configure them to do exactly what we want. However, we also have to perform maintenance on those servers, keep them up and running to do exactly what we want them to do. But then, if we go to the far right of the spectrum, we end up with something else, and that's software as a service, or SaaS, commonly abbreviated. Now, for software as a service, you might not realize it, but you're probably using multiple software as a service solutions every day. And that could be your email provider. It could be a specific chat service that you use with other employees. It's just a piece of software you're able to run with. You don't have to worry about configuring servers. It is just provided to you as a service. And in the middle of these two, we have something called platform as a service or PaaS. And this means that we're given a service that is configured for us where we simply need to deploy our customizations onto it. So it's in the middle between maximum control and minimum maintenance. So if you ever used like a WordPress host like WP Engine, you can simply drop in your code and you're up and running. They configure the WordPress install in the server for you. That's a nice example. Now there's also a platform as a service solution on AWS called Elastic Beanstalk. So with these different options, we can understand that there are different ways to use cloud computing. And these are your main cloud computing models. Now let us talk about cloud deployment models. Okay. See the first one on your left. The first model that we see here is public cloud. And I'm sure all of y'all have know these concepts and you'll have come across it before, but let's formalize it. So we are actually very clear about what we are dealing with where AWS is concerned. So we are formalizing these concepts. Okay, the first model is the public cloud. Sometimes people just say cloud. This is when you are deploying a solution onto a public cloud provider like AWS. And there are others here as well in the cloud space. There's Azure from Microsoft. There's a Google Cloud Platform. Then we have on-premises or private cloud. Now, large organizations, IT services organizations, are large IT service providers in India, for instance. Most of them have their own private cloud. So you can also sometimes hear people say just on-prem. So this is when you have a cloud-like platform in a private data center. So if you wanted to be able to have something scalable like you have with AWS, but you wanted to be able to do it within your own data center, there are solutions you can deploy from companies like VMware, for example, to have a private cloud. And in some cases, you will have what we call hybrid, meaning you have an organization that is leveraging both a public cloud, but those public cloud applications are working together with a private cloud within their own data centers. And so it's important for us to understand that for some, especially large organizations, they could be using both a public, private, or using them together in a hybrid model. Now, there is also some people also say there's a fourth model called multi-cloud, but these are your main ones, these three. So next, let us try and go through a few, how would you say, scenarios or use cases to try and understand, apply what we've been working on in this module. Let's run through some scenarios that are based on what we covered so far. Okay, so let's present the scenarios first. The first scenario, we have Roger and his company runs several production workloads within its data center. Now they use VMware to manage the infrastructure in their data center, but they want to use AWS and they want to integrate it with their data center for some of their new workloads. So using the two in like tandem. Okay, everyone got that so far? This is your first scenario. So in this case, which cloud deployment model would his company be following? Take a minute to go read through this again. Thank you, Sagar. We'll discuss the solution shortly. That's great. Awesome. Good. That's good. Yeah, everyone is thinking it through. That's what I really love to see that. Okay, so we have this. Very good. Let's see the let's see the next. Okay, now we are looking at cloud deployment models and not cloud computing models. Firstly, cloud computing models, there are three, as you see on your screen. Cloud deployment models, we have just covered three. Some people say four because multi-cloud is there. So look to this. This is which cloud deployment model? Choose from one of these. So scenario two. So here we have Eliza, and her company is trying to decide whether to fund a new line of business. And in this case, her team is looking to monetize a new emerging technology. Now, the new line of business will require some new infrastructure. So, obviously, beyond what they currently have. So, what benefit? We are looking at benefits now. What benefit of cloud computing would be most relevant to her company? If we go back to these are benefits. Choose from something over here. Okay. So realistically, they want to break into a new line of business. They want to set up stuff, but they need infrastructure. If they go for cloud computing, what benefit would be most relevant for her situation? And lastly, our last scenario, this is Jennifer. She is the CTO at an insurance company. And this is just a medium-sized insurance company. And they are considering moving to the cloud instead of co-locating servers, which means you're renting space in another data center, basically, right? Now they want to make sure that they have maximum control of the cloud servers. And they want to do that for security and compliance reasons. So in this case, which cloud computing model would they need to leverage? All right. So this is your scenario, and which cloud computing model? Choose from here. Infrastructure as a service, platform as a service, or software as a service. And this is our scenario. They want maximum control. And they are, of course, they're moving to the cloud. That's fine. This, otherwise, why would they be concerned? Very good. Very, very good. Okay, so good. People are understanding. Yes, thank you, Sampada and everyone. This is y'all are thinking it right through. That's great. So, so we covered quite a bit in this initial module in our course. So I would like to quickly review each of these things we've covered before we dive in and take a look at our scenarios. So first of all, we reviewed the we checked how to create an account for personal use. Following that, we examined how organizations leverage traditional data centers And we focused on a fictional company, Globomantics, and how they were looking to deploy a new professional social network. Following that, we explored the benefits of cloud computing, and then we reviewed the different cloud computing models. And then, and this is distinct, right? We understood the cloud computing deployment models. So with that said, let's take a look at our scenarios. Our first scenario was Roger, and the company was running their own data center where they were managing their virtual servers with VMware. And then they also wanted to work alongside AWS in the public cloud. So the deployment model, there are three that we discussed, right? Three kinds of models. So which cloud deployment model would the company be following? Well, the answer is hybrid because they were using both a private cloud in their own data center and a public cloud being AWS. And the question is actually which cloud deployment model? So there's public, there's private, and hybrid. Let's take a look at Eliza. They were looking to monetize a new emerging technology. So with this new line of business and the new infrastructure that would be required, what benefit of cloud computing would be most relevant to her company? Now, there are the benefits that some people did mention. There's elasticity, for instance. That is there. Very true. Agreed. Very true. But from an investment perspective, actually, well, of course, you don't have, there's also staffing you don't need, maintenance, scalability, all that comes in. Well, what would be actually the most important one? The pay as you go would work, would benefit her, Eliza, the most because you are transitioning from that large upfront investment to a variable cost. And all the other answers you're given are correct. That is true. They all benefit her, but pay as you go, this transition from the large upfront investment, which is how do you say, a stop? This is a showstopper for many startups. Now they transition from that to a variable cost. So this way they can try out a new emerging technology. They can try it out at a small scale and only pay for what they're using instead of having to make a large upfront capital investment. So that's part of the economics of the cloud. In this case, like economies of scale and everything come into play. Next, let's look at our last scenario, which is Jennifer is the CTO of an insurance company, and they were looking to move to the cloud. And most of y'all got this right first bang, straight off the bat. But they wanted to make sure that they had maximum control of their cloud service. So which cloud computing model would they need to leverage? Well, in this case, it's going to be infrastructure as a service, so IaaS, because they want to have maximum control. So just like they were running these servers in their own data center, and probably for security and compliance purposes, given that they're an insurance company. So insurance and the actuarial industry, actuaries, security is a big issue for them. So in this case, instead of choosing to do platform as a service or software as a service that would fully take advantage of infrastructure as a service to make sure they had that maximum level of control. So with that, we come to the end of this module on understanding cloud computing. Now next, let us move into what is AWS. Let's understand it from the bottom up. And this is a very important. Think of all these as all different modules, Each course, every day will be one course. And as a matter of fact, all of this will be available to you. For today, they're just some slides, there are no materials, but any materials that are necessary to work through our exercises will be available to you on my GitHub repository. I will share you all the link after lunch. So I will share you all a link and you all can update as and when stuff is put up over there for the different, for every, for the sessions on different days. It'll be available and you can download it from there, or you could simply clone it also. Now this is a very important module because we'll be looking at Amazon Web Services, how it actually comes to solve the web application conundrum or dilemma, the global infrastructure of AWS. How does AWS work, and AWS versus the rest of cloud service providers? Why are we taking a course on AWS? Why aren't we doing it on Google Cloud, for instance, right? So this is what we'll be doing in this module. If you'll excuse me a minute, I'll be right back. I just need a little water, a glass of water. I'll be back in a minute. Okay, so we can continue. So we were discussing, we are going to go and look at what is AWS right now. Now, before we did have, we started with the internet. We all know that. Great. So then Amazon Web Services actually became actually a dominant force in cloud computing. Okay, so what we are actually going to look at, we're going to take a broad look at Amazon Web Services and put yourself in the shoes of a decision maker at a organization. How can we empower you to determine whether it's right for your organization or your application? Maybe you want to launch something, a new product, a new business idea you want to implement. So this is not a mean feat. It's not a small thing. Deciding whether to go with AWS, not at all. And why? Because Amazon AWS, what freaks people out actually, and is the sheer multitude of individual services that interact and they work in an incredibly complex number of ways. I had mentioned at the beginning of our session today that AWS has a lot of moving parts. Now we've broken down this course into this training into something that makes sense. So we'll take it apart. And of course, this course doesn't assume you need any prior background in cloud computing or programming or anything or any exposure to Amazon Web Services. We're going right from the basics. Okay, so rest your mind with that. Now, that's why a lot of people find AWS can be a little overwhelming. Okay, so what we want to do in right now, we're going to try to cut through this complexity and boil down the key functionalities of AWS and how they can work for your application. So we'll approach this AWS infrastructure and services from a developer's point of view. That's what the training is all about. We look at what the end user sees, that is fine. But from a developer's point of view, what does the AWS infrastructure and services offer him or her? So we'll approach it as like from a user, from a user of the services. So this will actually require us to talk about how services interact, since that is the key part of developing for AWS. But we'll avoid covering how they work under the covers. That's not in scope, really. So initially, we are going to look at, in this module, we look at AWS as a whole and understand that problems that cloud computing is actually solving. So cloud is anyway definitely the buzzword of the century. So we'll take a practical look at what it means and why it matters to your application. Then we'll have an introduction to AWS and talk about how it works from a high level. Finally, we'll look at some of the AWS competitors, such as Microsoft Azure and Google Cloud, to understand how they stack up to AWS. All right. After that, following this, we're going to look at the core services of AWS. Now, these core services, there's no categorization as such, but the core services that you can think about are ones that the majority of applications will utilize. So broad categorization, we can do it like that. Core services, and then I refer to them as extended services, which you can add on to your application. So the majority of applications will use stuff like services like Elastic Cloud Compute for computing, Simple Storage Service for serving static files, Relational Database Service, also known as RDS, and Route 53 to handle domain names. That's why route. And open your application to the real world. After that, we'll take a look because we are going to do a deep dive into a lot of these. These are what I like to say extended services. So during the rest of the week, we'll be doing quite a respectable deep dive into these services. These are digital services that, so we will be actually going through this in detail, but later on in the training. So we'll expand on these core services by looking at additional services the AWS provides for additional functionality your application might require. Now, some of these tools, they use core services behind the scenes, and some make working with core services much easier. So we look at Elastic Beanstalk, which is an application container. You notice the use of Elastic actually quite frequently in the names of the services and offerings in AWS. Then Lambda is a serverless option for executing code. DynamoDB is a managed NoSQL database. You understand NoSQL? Totally on the other side of the spectrum from RDBMS. So NoSQL like MongoDB is the most popular, I think. Virtual private cloud for securing your services. CloudFront we use to put our files on a super fast CDN content delivery network. And CloudWatch we use to collect and store logs and alert you when your application fails. Okay. So we'll just take a look at these initially today. We won't cover them in depth because we'll be doing that much later on. But we'll get a good idea as how each can help our application. Now, AWS does a great job of making these services accessible to developers at all levels. Fine. So let us get into this wide world of AWS services. Before we start, we should talk about the web application conundrum. Now, traditionally, a software application is what? It's a collection of compiled lines of code delivered and running on a computer in front of you. This used to be all that there was about how it all worked. With the introduction of the World Wide Web, however, a new paradigm emerged where software applications would run on different computers miles or even continents away. So users of this said application did access it with the HTTP protocol and interact with it through the web browser. This is what we call the web application. Now let's go back and imagine a scenario where a friend Lisa is starting a new web startup. Now she's got some really shiny code, a really nice product. She's got a great business idea, very innovative, something that's been waiting around and nearly guaranteed to receive a favorable welcome. She's running the entire web application from a server connected to the internet located in her closet. Oh, you can do that. So as customers flock to Lisa's product, she realizes her server in the closet isn't working out so well, is getting hot, is messing, stinking up her wardrobe, is starting to run slowly. So the overhead of her on-premises, it is actually on-premises, right? The server's in her cupboard. It's on-premises. This overhead of her on-premises hosting solution is hurting her business. Now, the difficulty in being flexible and scaling up quickly in response to consumer demands is costing her sales. This is the thing. This is the web application kind of conundrum. Your business grows so fast, you can't keep up with it. You can't respond to your customers. You can't scale rapidly. Finally, growth tapers off and goes to zero or negative. Now, Lisa's friend Gary works in a large enterprise company, and there's very similar complaints. Now, his small team has to interact with a bureaucratic process to have virtual machines provisioned every time they want to test out a new feature. I think all of us can attest to that, whether you're the owner, you have difficulties in provisioning, or whether your staff, you have difficulty in obtaining that provisioning. So just this process to have virtual machines provisioned every time they want to test out a new feature is a long story. So due to the overhead costs of such hardware instances, he's forced to share a physical box with so many other members of his team that his workflow is impacted. It slows down his development time. Maybe he has to share, so he has to sit. But he might get a lot of time to play ping pong, right? Anyway, web applications practically cry out for a different solution to solve the many woes presented by on-premises hosting. Now, modern business won't wait for physical demands, and speed to customer expectations become a serious edge for competition because you lose out otherwise. Your market share drops. It's not a joke. So the cloud industry began to provide a solution to small and large businesses alike that needed an affordable and flexible way to serve web content to customers. By abstracting away the physical hardware and then removing much of the configuration, both virtually and geographically, the cloud is able to get companies up and going quickly. So most pricing models allow companies to pay for what they use instead of a physical machine. That's the pricing model for AWS and other cloud providers. That's the thing. And as cloud service providers improved, deploying an application to a new machine became as easy as a single click. We'll talk shortly about Heroku, for instance, which I have used to host some websites, full stack websites or mean stack websites. I've used it. It's great. So it's no surprise that the cloud grew as fast as it did. It's especially popular with startups. Of course, startups would be uh, benefited the most by it because it enables them to move quickly. Now, enterprise companies are flocking to the cloud more and more. They're finding a lot of value in the different pricing models and the reduced liability. That is also a key factor. So they don't have to also manage their physical data centers. So we can actually say the cloud has solved the web application's biggest conundrum. So this is the background, how cloud has actually evolved to the state that it is in today. So how did Amazon Web Services? It's a bit of a history lesson, I know, but you should understand how it came about. So let's just spend a few moments talking about AWS and its beginnings. All right. So around 2003, I think, there were some engineers at Amazon figured out that not only did Amazon need standard server configurations, but there was a potentially huge revenue stream waiting if they could sell the same capabilities to other businesses. It only took 1 year after this proposal to offer a service for businesses for cloud computing that AWS was actually christened. And their first offering, Simple Queue Service, was launched in like around 2000. Then this was just the first of a deluge of services that added more and more functionality to satisfy the needs of modern web applications. So as I mentioned before, there's a lot I'm aware of web services, many for AWS, but of course, not possible for us to go through each and every one of them. We will look at the core services in this training, and then we look at the extended services or the advanced, or okay, that's what we look at. That'll be enough to get going. Now, Amazon wasn't the first company to identify this business opportunity, but they were one of the first to fill it so successfully. So in the plainest possible terms, let's talk about AWS. So at its simplest, AWS is a collection of cloud computing services that can be utilized independently or run in tandem to run a computer application. At its simplest. Now to break this down, we call it cloud computing services because the services are running in some magical data center somewhere, and marketing people like need some simple terms for these things. So that's why it seems that this is how the term cloud came about. Maybe, okay, but it was a marketing concept. Now these services provide all types of computing operations. Now this is very important to understand. It's not only used for web applications. That's not a requirement at all. Basically, these services all provide some type of computing operation, whether it is literal computing, messaging, routing, or something else. So you can run any type of application with AWS. And as a matter of fact, many universities, government agencies, and corporations, they use the flexibility of AWS to process large amounts of data. And you can understand, especially universities like running, statistical analysis or data science type programs also. So the flexibility of AWS to process large amounts of data or run a lot of computations, that is also in demand by universities and government agencies and different corporations, because it'd be very difficult to set up and also expensive to set up on premises. Now, Amazon Web Services is simply one of the many providers of cloud services. They have distinguished themselves as one of the most reliable and also as having the most geographical footprint. And we will see that when we come to an upcoming module on the Amazon global infrastructure. We will see that. Now, large tech enterprises have the entire infrastructure running on AWS, which is a huge vote of confidence for the service. That really is. Essentially, if AWS went down, there'd be no Netflix. Amazon established themselves in this market by having like a fierce focus on creating services that solve their customers' needs, offered at an affordable price. Now, why would someone want to put their entire business on AWS? It seems like a huge gamble, right? Well, the two biggest reasons are cost and scalability. So let's look at cost first. Let's return to our friend Lisa's web company. Now, without AWS or a similar cloud provider, she would be looking at first buying a server for serving the web application, perhaps a separate server for the database, cables to hook it up to a business speed, I'm saying business speed, broadband internet connection, and she made a need a dedicated room to house all of this hardware and keep it from physical danger. All of this before she has even one customer paying for her service. So it seems a little daunting, right? Now compare this wall, what you see on the slide before you, it's a wall of upfront capital to the cost of hosting on AWS. This is what you need to run your application on AWS, and that's this, nothing. The upfront cost of AWS is nothing. With AWS, you only pay for what you use, and usually on a monthly basis. So once these customers start signing up and paying for your service, you'll already have the money to pay for the web application they're using. Not to mention that instead of dropping thousands or hundreds of like money in whatever currency you're paying for to purchase hardware that may fail and have to be replaced, you're paying pennies on the hour for some of the services that AWS is providing. And don't forget that AWS themselves, being so large, they have reap a lot of economies of scale. And that is what they're passing on to their customers. Here is something nice. You could check it out yourself. It even provides handy calculators to help you estimate the price of your intended usage. So if you decide to go beyond the free tier and actually pay for one of the paid plans, I recommend using these pricing calculators to estimate what your cost will be before you actually go ahead and choose any particular plan. Okay, now the other, like we talked about before, the other big reason to choose the cloud and AWS is scalability. So we've talked about low cost. All right. So unfortunately, Lisa has to be dragged through this again. But let's use a company as an example. Imagine that she pays for all the infrastructure upfront and her application ends up being wildly successful. Customers are flooding onto her platform to the extent that her initial server setup is overwhelmed. Someone posted something on Reddit, something complimentary, and now her web application dies from too many requests. Isn't that ironical? So she needs to scale up, but her only option is to order another server, which can take days or maybe even weeks to arrive. In the meantime, her user experience is suffering and growth may drop off or disappear entirely, killing off her business before it even had a chance. Enter AWS. By deploying her application to AWS, the scalability concern is resolved in actually seconds. With AWS adding more servers, running her application only takes a few clicks. The servers start up immediately, and her application can be up and running in around a minute. So pricing is the same as before, paying only for what she uses. So once again, there's no upfront cost for spinning up a new instance of the web application. So with both of these as the defining features of the cloud and AWS, I hope you can now see why the adoption of these types of services has spread so quickly through the software industry. Now, there's one more characteristic of AWS we just mentioned briefly so far. Actually, it deserves its own module. So after lunch, we will actually go through this in a little bit more detail. It's important for us to understand the global infrastructure of AWS and how it relates to scalability and availability. But for now, let's just take a brief look at what it's about. So what we are actually talking about is the ability to deploy to different locations with AWS. So this is not a small thing. This is done as easily as actually as scaling or just selecting a few different options while deploying your application. AWS will take care of the rest. Now, there are two things that we should think about when deploying a web application. As you'll probably know, that is, for any serious web application, we must think of reducing latency and adding redundancy. So what do we mean by this? If your application is not a web application, meaning users don't access it remotely via browser or other protocol, then latency is probably not so important. But with users, the latency or time it takes for requests to cover geographic distance is one of the hardest challenges to overcome. So what is latency as regards a web application? It essentially it's the time it takes the bits or bytes from your server to the user's browser and vice versa. The packets of data that are sent, right? So the biggest contributor is what? Is the physical distance between the server and the user. Agreed? So basically, the only way to reduce latency is to get your web application closer to the user. Now, if you have are self-hosting, you would have next to zero control over that. Unless you want to drive around the world, like installing servers in, gas stations and restaurants and stuff. Or on the sidewalk. That's hardly an option. Okay, so the ability to have servers running in different parts of the world closer to your customers is a huge advantage in this industry. Now, AWS has the most data servers, and that's why we are going to, in the next module, we will talk a little bit more detail about the geographical infrastructure of AWS. It has the most data servers, the most geographical areas of any other cloud service provider that you can think of. So that means you can solve the latency problem best with AWS. Now let's talk a minute about how AWS is organized geographically speaking. There was really something I would have loved to show you all. It was an AWS global infrastructure visualization that they had available. It was like in 3D, and you could move it with your mouse pointer, and it was quite nice. But now, for some reason, it's not available anymore. So they just got a more or less static screen available. If you type in infrastructure, AWS or Amazon, it'll come up to something like that, more or less static. But they had a beautiful visualization at one point, a globe with points and a net showing the network between different data centers and the availability zones, which we'll talk about soon. But anyway, they removed it, it seems. If you look at this slide in front of you, it has many, AWS has many regions throughout the world. Regions are actually physical locations where certain services are hosted. Now, these regions increase often, and in 2016 alone, AWS has announced they will launch 5 new regions, bringing their total region count to like 17. Now, usually, just to give you an idea how this works, having a server instance available in the same country or continent as the user is a sufficient reduction to latency. So now you see why anyone around the world, this is a map of all the regions, these points. If you look at India, can you see my mouse? The blue one is actually Mumbai. And right next to the blue dot, circle rather, there's an orange. That I think is Hyderabad. That is coming. They're shortly to be installed. At the moment, we have one in Mumbai, and that's a good reduction for latency. Just having one per continent. So that's pretty good. I mean, it'll sufficiently reduce latency in your web application. Now, within each region, AWS also has availability zones. Now, an availability zone, you can sort of represent like this. It's a collection of data centers that have completely separate power, networking, and connectivity, but are connected via hyperfast fiber optics, right? So this allows an availability. You'll come across this term. This is the terminology we use with AWS. Data centers, availability zones, regions, all this. So this allows an availability zone, as you can believe, to be extremely fault tolerant. So if someone like forgets to pay the electric bill at one data center, the others will provide a redundant failover. So this is where failover comes into play. Okay. By scaling your application across several availability zones and or regions, you can achieve nearly unlimited uptime for your application. So this is where AWS's global infrastructure contributes to your relative uptime. Now, there have been instances in the past where AWS region connections have gone down. That is true. But there's not yet, and hardly likely also, there's not yet been a scenario where multiple regions have gone down simultaneously. And if you look at the setup, it seems highly unlikely. Very low probability. Now, it can be a little scary at the thought of an AWS region going down and taking your app with it. So let's talk a little bit more about that. If you visit this URL over here, HTTP status awsamazon.com is nothing to do with your personal app. It's the status of all the Amazon data regions and data centers around the world globally. So Amazon hosts this page. It shows basically current service statuses across regions, as well as, you know, the status history at this status.awsamazon.com. It'll look something like this. You can take a look at it. You can go to your browser also. It's there. If you go through it, you scroll through it, you'll be hard pressed to find a performance issue. Not to mention a connection issue. So it's just take a look. Each AWS outage is a major news event because it impacts popular sites like Netflix. As far as I remember, there's not been more than one per year lasting a few hours each, from what I understand. So frankly, there's actually very good such stability. Now, with that option to easily host your application in multiple regions, there's where can you find a more trustworthy service actually to depend on? Now, next, let's get into how AWS actually does work. But I believe that we've covered a lot in our morning session. So it's our lunch break, I believe, right now. So I will see you all back at 2 o'clock, I believe, right?
Yes, sir.
Okay, so go ahead, everyone, please, and I will see you all back at 2. We'll carry on. We'll get into how AWS actually works. We look at the global infrastructure in a little bit more detail. Then we'll go through actually, we have quite a lot to do. We have to look at the core services in some detail, as well as we'll wrap up by looking at going and discussing identity and access management, which is very important. So go ahead for your lunch. I'll see you all back at 2.
Dear participants, the session 3 will start at 2 p.m. sharply. All of you are requested to join in the same link.
Hello, Madam Anjali. Am I audible? Can you hear me?
Yes. Yes, sir, you are audible. Can we
Okay.
start the session, sir?
Now, shall we start?
Yes, sir.
Okay, great. Fine.
Okay.
So let us continue. But before we do anything, as promised, here is the repository. So please access this over here. I'm sending it on the chat. Sharing my screen. So you can see this GitHub repository, okay? Now, so just click on that link. It'll take you to the GitHub repository for cloud computing, and whatever slides are there, you can access them. It'll be the same from day to day. So please, you can do that now if you wish. There's a little button over here for code. You can click on that. If you have GitHub Git installed on your computer, on your system, then you can simply click this copy button over here, and then you can clone it into whatever project directory file folder on your machine. Otherwise, you can simply click download zip. So nothing's going to be subtracted. I'll just be editing some stuff and adding, for every day. The slides and any supporting materials we need for the class will be over here. As regards any hands-on, if any supporting materials needed, maybe some code snippets, for instance, or small programs, that will be over here. Okay, so I think everyone should have that link. It'll be the same link every day, just update it. So now we will continue on with how AWS actually works. Then we'll continue with understanding, go into a little bit more depth with the AWS global infrastructure. We covered a little bit of it. Then we look at the core services of AWS. And finally, we'll look at identity and access management. So I believe we left off over here. Okay, so as described before, AWS is a collection, basically, of services that interact together for enabling an application to run. Now, what is a little bit disconcerting and people feel overwhelmed because of the multitude of services that are provided, as well as the the myriad ways in which these services interact with each other. That is, but we will take it right from the basics. So no worries. So first, I thought it'll be helpful to see explain how these services actually interact with each other from a high level. Now, nearly all services interact with each other over typical TCP connections. It really depends on the service as to which port it might use, right? For instance, each type of database you might use has its own port of choice. MySQL, for instance, is like what on your local machine is 3306. Oracle has something else. I think you look at the Oracle UI, that'll be 8080. It'll take up your port 8080 on your computer. Anyway, so there's not a single protocol that all services can use. So usually you are initiating these connections in your application by making requests to the AWS services. Now, if you create all your service instances in the same virtual private cloud, then they will have local IP addresses and you can make super fast connections to them. That makes sense. Now, while beginning our development with the various services of AWS, it's not like an all or nothing process. Now, since all of the services interact mostly the same on your local development machine as in the cloud, you can add and build on these services as you like. For example, a common first step for a content management system web application might be to connect to a database service in AWS. Then you could connect and begin using S3 for static file storage. You can work with these services exactly the same on your development environment as you would in the cloud, making the development to deployment experience as pretty painless actually. Now the biggest change once you move your main application to the cloud is actually securing it. Now that is something you can do while your app is being developed locally. So once in the cloud, connections and permissions between each service are managed via security groups. See the firewalls on the screen. They are. Essentially, they are light firewalls around each service instance. Now, how is security enabled in the cloud for AWS? This is done with pure configuration. Like I had mentioned earlier, what we are doing in this training is actually learning how to configure stuff on AWS. There is development, there is some code involved, depends on what you are trying to achieve. But a lot of it is configuring your services appropriately, your EC2 instances, configuring them appropriately, all that. So where is it done? Is done on the web console, which you have. Once you log in, you have access to your web console. That's where all of that is done. Now, most of the bugs, you will get bugs, but most of the bugs with services interacting in AWS are not actually the fault of AWS. They're generally from misconfigured security groups. So you have to be very careful when setting up your security groups. And we'll see that when we set up our own security groups and we create our EC2 instances, deploy a web server, we'll do that tomorrow. Okay. Now, in the following modules, of course, we'll go into a lot more detail as far as individual services go, but this should serve as a basic understanding for how things are actually working in AWS. Okay, so since this is a course actually targeted for development and developers, okay, how to actually practically implement stuff on AWS, let's the details of the infrastructure, let us keep aside till we need it, at least. Now, how does AWS stack up against the rest of cloud service providers? They, as you know, they're not the first or only player in cloud computing. In fact, there are many companies providing robust solutions for the cloud. Honestly, it can get a little confusing sometimes trying to understand the differences between them to make an informed decision. So I thought it'd be good in this section. Let's talk about some of the more popular competitors and the differences between them in AWS. So you can make an informed decision even when you want to whether you want to specialize in learning about AWS vis-a-vis some other competitor like Azure for instance. So let's talk about the elephant in the room, Microsoft Azure. Now, both companies, they reside in the Seattle area, actually. That means the competition between them is that much more fierce. Azure was started by Microsoft around 2010 as the cloud became a major player in computing. Now, the general model of Azure is kind of the same as AWS. It provides a range of computing services with on-demand scalability and flexible, that's the operative word, flexible pricing. Now, talk about pricing. Actually, it's difficult to compare pricing between these two services because they don't offer the exact same sized offerings. It does appear that AWS is more competitive, but that shouldn't really be the main factor when deciding on a computing platform for your organization. Actually, the pricing is close enough between the two. So what are the differences between Azure and AWS? So on this slide, we can see Azure actually has made big strides and leaps and bounds and is caught up to AWS in terms of cloud offerings and global reach. So those aren't as much differentiators actually as they once were. Now, one of the major differentiators in running Microsoft products such as Windows Server and SQL Server in the cloud. That is their advantage that they leverage. Now, for instance, recently Microsoft announced they removed the option from their consumers to migrate their licenses for these services to competitor clouds. So you can understand the implications. Okay, so Microsoft is likely to begin consolidating their products onto Azure. How far they progressed as of now, I don't really know, but this is quite recent news, I think. So Azure makes it the easiest and cheapest place to run Microsoft products. So if you currently use or would need to use Microsoft products in the cloud, then Azure is probably the best provider to use. Then again, we aren't going to get into it, but working in both of the consoles feels different. For instance, for someone who's familiar with AWS's UI, the Azure's interface will feel much more cluttered. You know, they try to actually provide a experience, a one-stop shop kind of thing for all the available services. So it's a little cluttered, the UI, not as tidy and user-friendly as AWS. Now the AWS console actually, you to navigate it, as we'll see shortly. When we set up we just demo setting up an EC2 instance. Actually, it requires more clicks because each service has its own dashboard portal. Anyway, there's a lot more to compare between Azure and AWS, but these are, I would think, the basic differences. Okay, now in 2019, there was Gartner's Infrastructure as a Service Magic Quadrant report. They added Google Cloud, also known as the Google Cloud Platform, to the leader section. So it joined AWS and Azure. Now, this is a big win for Google as they continue to grow their market share. Basically, they're attempting to take the third place spot from Alibaba Cloud. So let's take a closer look at Google Cloud. What is Google Cloud? They had their first cloud offering called App Engine in 2008, and they released it to the public in 2011. So around that time. Now, since that time, they've started adding more services and consolidated them into a single cloud platform offering. So, how does it rate against AWS? This does seem to be some specialization in the big data, the AI, and the Kubernetes spaces. But otherwise, it's pretty hard to see any real like differentiators between AWS and Google Cloud. Their data reach and their locations seem similar. Now, the market share of AWS does overshadow Google's at this point, but the Google Cloud's web console is not fully mature. So as Google Cloud grows, it'll be interesting to see how they differentiate themselves from AWS and Azure. And how do companies differentiate themselves? By their product, their branding, or the services they provide, for instance. So let's, the last service provider is actually one of my favorites because I use for development a lot and for deployment, actually, not development, deployment. So it's familiar to quite a few developers. That's the provider Heroku. Originally, Heroku started as a cloud computing platform for Ruby on Rails applications. And that was way back in 2007 when Ruby was one of the hottest like web languages of the day. Then, for many years, it was exclusively Ruby before they started expanding, and now they support just about any major web language. Like, for instance, I've normally used Heroku for deploying full stack applications with Angular and maybe different backends. So they're great. I mean, occasionally I had a few little glitches initially at startup, but that you can resolve it relatively quickly. So anyway, in addition to languages, they also began to introduce more and more like connected services, like databases and enterprise solutions. Now its main value proposition is its simplicity to deploy and scale that application. It's actually very easy to, and it's quick to get started. You can take a free account, or companies can take a commercial account. It depends, but it's pretty simple, and that's what we need, right? Simplicity. Development is one thing. Deployment can be a nightmare. And also, you can actually deploy from the command line, which is very slick. In a few commands, you can deploy a full stack web application, for instance. However, with simplicity comes a trade-off. So lack of options is one. So Heroku focuses on doing one thing well, that's simple and streamlined application hosting. And they succeed from over many of their competitors, including AWS. Unfortunately, their services don't offer many of Amazon Web Services options, and their global reach is only 8 regions. That falls far short of AWS. So that's it. We've reached the end of the model. This was our introduction to the world of Amazon Web Services. Okay, that was quite a bit to cover because we're going to go into even more depth into AWS throughout this training. Anyway, so let's go over what we've learned in this module. We started by discussing web application hosting and the main drivers for moving it to the cloud. So Amazon grabbed onto this new paradigm and it developed a business to support and profit of cloud computing in the form of Amazon Web Services. That was the birth of AWS. Now, the two major drivers of AWS popularity continued to be pricing and scalability. And we talked more in depth about the global reach of AWS throughout the globe. We talked about how AWS services interact and what you can expect when working with them. Finally, we discussed a few Amazon's competitors like Azure, Google Cloud, and Heroku. Okay. So hopefully this will help you that when you need to perform a comparison and which is the best solution for your use case. So shortly after coming up, we'll look at the core services of AWS. And then we look at how we can actually configure an EC2 instance. One of the core services of AWS, we'll need a console for that. So we'll get into that. Now, these core services, the module after this actually, these are the basic services that you're likely to use no matter what type your web application. Okay, so a little bit more technical introduction of really what's going on. So what are we going to look at? We are going to look at EC2, which is Amazon's cloud computing service, which is the most commonly used service on AWS. Next is S3, which is the essential service for storing static files. It could also be the most used service, but it's a toss-up between EC2 and S3, really. Because most web applications require some sort of database after all. Anyway, so we look at relational database service, and finally we'll look at Route 53, which is a service for configuring URL routing to your application. Okay, so with these 4 services, we'll cover the main things that we need to get started with Amazon Web Services. So before we move on, let us take a look at a global infrastructure in a little bit more depth. So I hope my screen is visible now. Maybe sometimes it takes as a lag, but it comes up, right?
Yes, sir, it is visible.
Okay, great. So let us actually look at Amazon's global infrastructure because that is key to understanding Amazon's presence, frankly. Frankly speaking, is that's the key to it. This basically, what are we going to discuss in this module? It's how AWS actually deploys the services globally, and then how we can access them when we're using this platform. So we are actually talking about 3 different types of infrastructure. These are AWS regions, availability zones, and edge locations. Okay, so over the course of this module, we'll walk into this in some bit of detail. So let's take a look at what we are going to do. First, we are going to be reviewing these 3 elements, and so that we can understand how we can actually take advantage of them. First, we look at the use of AWS regions, and we'll understand how regions consist of availability zones. And then we'll review the purpose of edge locations. And then finally, we'll wrap it up with a summary. Okay, so let's dive into the concept of AWS regions and availability zones. These are 2 elements of AWS's global infrastructure. Now, first, it's important to note that each region is located in a specific geographical location. What do I mean? I mean, basically, it could be centered around an area, like Northern Virginia, or in a specific area like Singapore. Now, each geographic location has a cluster of data centers. Now, that works together, so a region is much more than just a single data center. It's currently, AWS has launched 22 different regions. Some are public, some of these are not available to the public, but currently there are 22 globally. But additional regions are being announced. And if you go on the AWS website, on the last session slide, we had seen one slide with the show section, what is in place and what is coming up, the ones in orange. So, but anyway, the most current information, of course, will be on the AWS website. So if you look at a global map, you'll see the spread of AWS regions is pretty great. These are your AWS regions. You can see India, for instance, has just one, that is Mumbai. But in the previous slide, there was also what was in a hollowed out circle with orange. That I believe is Hyderabad, which is coming up shortly. So we have quite a few. Let's see. We got, of course, the United States. Of course, we got some that exist in United States, as well as Canada, South America, Asia. Now, there's a lot of different regions, areas where AWS regions exist. And there's probably quite a few that are getting ready to be added by AWS. So these are your AWS regions. Now they operate with smaller units called availability zones. Let's talk about these. Availability zones consist of one or more data centers. So here's where we get down to the data center level. Now multiple availability zones are included with each AWS region. So that means that at minimum, each AWS region has 2 availability zones, and at minimum, each of these availability zones has at least 1 data center. So the smallest number of data centers that can support an AWS region would be 2. But that will include many, many more, actually, in reality. Now, these are located within the geographic area of the AWS region. So you are not going to have availability zones that are far, far away from the region area. No. Locational proximity. That's where they are going to be. Now, in this case, that geographic area will house all of the availability zones. What do the availability zones themselves have that they called availability zones? Basically, they have the redundant power, networking, and connectivity. Okay? Redundant power, networking, and connectivity. So AWS tries to make sure there are no single points of failure when it comes to their global infrastructure. I think there'd be over 69 availability zones that have been launched. Now, let us take a look at just a small piece of the AWS global infrastructure. So over here, we got these two things together. This is the US. If we look at regions within the US, we currently have 6 different regions. Now, 4 of these are in public regions, and 2 of them are what is called GovCloud, G-O-V cloud. Now, as you probably guessed, this is what the cloud that AWS has developed for the government. So There are multiple availability zones that make them up. For example, if we see Northern Virginia, that's actually called US East 1. There are 6 different availability zones that support that overall region. Okay. Now, the reason that availability zones exist is because of this concept. Is the extent to which an application is fulfilling its intended business purpose. So if you have an application for a company that's mission critical, but is down all the time, that would be a low availability application. But if we have a situation where we have an application that is mission critical and it's up all the time, we could call that a highly available application. And that's done by making sure that no single point of failure will lessen the application's ability to be fully operational. So the concept of availability zones is that if we deploy applications and experiences across multiple availability zones within an AWS region, we minimize any single point of failure as being responsible for taking an application down. Let's look at the naming convention. How do we name both regions and availability zones? So here, it's common to see a notation like this: US -East -2A. Let's talk about what this means. So first of all, the first area within this name is a high level area, for example, US. And then a sub area, so the eastern part of the United States. And then we'll have a given number because there could be multiple regions within that area. And then we have a letter designating the availability zone. So when we look at this, if we look at a small segment of this, here's how we get the region name. So the region name in this case would be US East 2. Actually, that is located in Ohio. Now, if you want the full availability zone name, we would have US East 2A. And if we had other availability zones, they would be 2B, 2C, like that. Now, if you look globally, here's a sampling of the AWS regions that we have globally and the region identifier. So you can see from US East Ohio all the way to South America, Sao Paulo is SA East 1. Stockholm, for instance, is not here. EU North 1. Okay, now the next concept that we need to cover in the AWS global infrastructure is a concept of edge locations. So let's talk about edge locations. First of all, edge locations are used as part of a global CDN, a global content delivery network. Now there are 2 specific services within AWS that leverage these edge locations, and we'll be covering them in this training on a deeper level, a more practical aspect, somewhere towards the end of this week. CloudFront. Okay. So the first of these is Amazon CloudFront. This is AWS's global content delivery network. And the second is Amazon Route 53, which is Amazon's DNS service. DNS, domain naming service. And these are the 2 services that will use these edge locations that exist around the world. Now, currently, I think there could be 200 different locations. They have edge locations. Okay. I mean, 200 different locations are designated as edge locations. So this means This is the most common, the most prevalent part of our infrastructure within AWS. And what this does is to allow AWS to serve content from locations that are closest to users. Remember what we did in our last module, I think? Latency. If you are hosting your own web application, you have very little control over latency, network latency. And one factor about latency, how to reduce it, is the factor is actually distance from the end user. So this is how AWS, it can reduce latency for its end users by serving content from locations that are closest. Now, this is our edge locations. You can see India has 3. America's got a ton. Australia has 3. This is how it plays out globally. And because of this, latency can be managed very efficiently, effectively by Amazon Web Services. So what is so suppose we're producing content over here. If you look at the US, for instance, if we're producing content at Atlanta, Georgia, for example, suppose, it'll be nice to have a server where content can reside in Singapore. If we have users that are going to be viewing our content from there. This is what these edge locations bring to the table, right? So you're producing something. It could be halfway around the world, and actually it is. You're producing way across the world. You could be producing in Mumbai, but you're serving content to Indian movie buffs in Australia. Now, that'll be what would be the best is to have a server where content can reside, like in Australia, and that would be that. Then your game is on. So why I'm talking about this is because this is an essential differentiator in terms of the AWS global infrastructure to have such a wide area where we can make sure that our users can fetch their content from. So that's how edge locations, just the name edge, but it's a major differentiator for AWS global infrastructure. Now, there was a nice visualization. Unfortunately, it doesn't exist anymore. I searched for it because I wanted to use it for this class, but it seems to have been taken down. So, but if you go to Google and you Google it, AWS Global Infrastructure Visualization, it'll just redirect you to a page with a nearly static, that dynamic. It was actually a 3D image of the globe. Very nice. You could actually rotate it with your mouse and you could see all the edge locations, the availability zones, the regions, everything. And it was a nice learning tool, but it's not there anymore. Anyway, let's take a few scenarios, right? We're going to cover 3 scenarios now that will just help us gauge how well we actually understand the concepts that have been presented in this module. So here's our first scenario. Here we have Jane, and her company is looking to transition to AWS. Now they're going to be starting with just a few workloads, and they'll be moving other workloads to the platform later. Now it is a requirement that they store their backup data in multiple geographic areas. Now with this being said, Which element of the AWS global infrastructure will best suit the needs that Jane's company has? So that's scenario 1. Okay. Which element? Let me back up a little bit to give you all some clue. We got AWS regions, we got availability zones, we got edge locations. Remember what an AWS region is? It's got a cluster of data centers. Availability zones, actually, this is where we get more granular with our data centers. There are multiple zones included with each AWS region. Our edge locations allow AWS to serve content from locations closest to the user. Okay, so their requirement is to store backup data in multiple geographic areas. Which element of the AWS global infrastructure will best suit this need? So that's scenario 1. Now let's look at scenario 2. Here we got Tim, and Tim's company serves content through their site to users all around the globe, and they're looking to optimize performance to users around the world. They want to leverage a content delivery network because they've heard that if they can get their content on servers that are closest to their users, this will improve performance. Actually, it will. Remember our discussion on latency. Now, in this case, which element of the AWS global infrastructure will best be used in this case? So that's scenario 2. Now for scenario 3, we have Ellen. And her company is transitioning one of their legacy applications to AWS. For this specific application, they require an uptime of at least 99.5%. That means it's up 99.5% of the time. Now they want to be sure that any issues that at a single data center won't cause an outage. This needs to be a highly available application. So for Ellen's company, which element of the AWS global infrastructure supports this need? Okay. Okay, so we've covered a lot of things around the AWS global infrastructure in this module. Let's quickly take a look back at what we've covered. First, we reviewed the 3 elements of the AWS global infrastructure. We then understood how to use AWS regions, and we've understood availability zones within those AWS regions. We also looked at the naming scheme for both regions and availability zones. Then we reviewed the purpose edge locations. So now let us review our 3 scenarios. So in our first scenario, Jane's company, remember, was looking to transition to AWS, and they wanted to store backup data in multiple geographic regions. And the question is, which element of the AWS infrastructure will best suit their needs? Well, in this case, the key phrase is multiple geographic areas. Now, because they're looking to store this data in multiple areas, this means that we're looking at AWS regions because AWS regions each exist within one single geographic area, right? So if we're going to store multiple geographic areas, we need to utilize multiple AWS regions. So that is the key, multiple geographic areas. Scenario 2. This is Tim's scenario. This you all might have guessed, or not guessed, reasoned out very quickly. His company is looking to serve content to users around the globe, and they want to leverage a content delivery network, or CDN. is he's going to be leveraging the AWS edge locations. This means they're going to be using a service called Amazon CloudFront. So we learn more about this in an upcoming course during one of these days. Now, this specific service utilizes the edge locations around the company. So when Tim's company, say they want to send their content out to users in the United States or users in Singapore, they can be sure that those users are finding a server that is relatively close to them, and that should improve the overall performance. Now let's talk through our third scenario, which is Ellen. Ellen's company was looking to transition one of their legacy applications that needed to have a high uptime. And they wanted to be sure that issues at a single data center didn't cause an outage. So that's going to be the AWS availability zone. The reason? We want to make sure we can deploy an application across multiple availability zones within a single AWS region, right? So by doing this, even if there's a significant issue that happens at a single availability zone, it won't cause the application to go down if it's been constructed properly. Just some thought-provoking questions over there. So that concludes this module. Now, we will look at the core services of AWS. But okay, but before we do that, there's something I'd like to introduce you all to the AWS Service Catalog. All right. And let's do that before we take a break at 3:15. Actually, we are going to get into the core services, but how do you actually requisition them? How do we provision them? How do you even request for them? So I thought we spend a little time on that. It's a very short module, but it'll contribute to our understanding of services, how they're provisioned, and all that stuff. Okay, so let us go with that. Because AWS has a very unique way. AWS actually has a very unique way of its service catalog is pretty unique, and it's something that you should have some familiarity with. So what we are actually learning with core services is what core services actually are, how they're built up, and how you deploy them, how you configure them. The pricing we'll go into a little bit. EC2, we'll look at a little bit more detail, the pricing. But how do you use the AWS service catalog? So what this does, the AWS service that helps you create and manage catalogs IT services that are approved for use on AWS. Okay. Now we'll just walk through how the service is used and the user types. When I say user types, I mean roles, of course. So the user types that can access the service. Then we look at some benefits, some best practices and use cases. Now, what this service does is enable organizations to create and then manage catalogs of approved IT services. Okay. So what is it exactly? Now, organizations benefit from the AWS service catalog because their end users can find and then launch only the approved products that they need from a catalog that administrators control. All right. So from an organization's perspective, this is what we are looking at. How do you actually manage your services? You don't want everyone ad hoc to be requesting Amazon AWS services, you'll go bankrupt. How do you actually manage it? So that's why I thought to include this short module into our program. Okay, so anyway, it enables us to create, manage, and distribute catalogs of approved IT services to our end users. This means that end users can then access the products they need quickly and deploy them easily. So on the slide in front of you, consider the following scenario for a moment. Say your end users need applications deployed, of course, but they are more end users than they are admins. Who are able to deploy those applications. Now you can see how the few admins that are there are ready to tear their hair out. Now building and maintaining these apps will take a lot of time and effort, not to mention that if they are regulated workloads, compliance requirements, let us not forget, need to be applied and maintained. You're probably aware that if you shift an app to the cloud, you will have a lot more compliance requirements than if you run it on a dedicated hosting server. You know, for some time, from my personal experience, I was working on a program and program actually domain type of application. So it was a program management kind of application utilized by the whole company, one of the largest IT service companies in India actually. Now, what was that? That finally, a lot of these, it was a horizontal actually, so it was deployed over the internet. Now the organization brought in their own private cloud. So a lot of the applications which were on our dedicated hosting servers, they were to be moved to this private cloud. And they had, of course, a department that would oversee all the security related to applications deployed on the on this private cloud. Now, they would evaluate all these applications that were about to be deployed, and before they gave them the go-ahead, they would check for website vulnerabilities. So, you know, the website shouldn't be open to CSRF or XSS attacks and SQL injection, that kind of stuff. So that was my thing. I got a report back saying that these are all the vulnerabilities in your security, in your application. These have to be fixed before they can be deployed under this private cloud. So that was my task. And when I actually checked myself, I found that there were some glaring vulnerabilities. I mean, really glaring. But this kind of application was being deployed on the internet, and for many years, nobody even noticed. But when you deploy on the cloud, the point being that you cannot, there are far more stringent security and compliance requirements than we ever used to have when we used to have these dedicated servers, the traditional hosting servers. Far more. So, in a scenario like this, there are compliance requirements that need to be applied and maintained. Now, if only there was a service that allowed end users to launch applications while still giving the admin the ability to ensure that all of their security controls have been applied. Now, over here, enter the AWS Service Catalog. So let's take a closer look at the service and some use cases. So how exactly does this work? So say an end user needs to deploy an application in the AWS account, but they don't understand all of the resources or how to set it up. They could create a ticket. Every organization's got an IT service desk, and they can go through IT. Now, oftentimes, not always, but oftentimes this can lead to a bottleneck and a waiting period, a couple of days or more. Now, instead, administrators, we are talking at the organization level, of course, right? Administrators can author a template or templates for their end users. Now, this template can then be actually handed back to them and deployed. So no more waiting around, no more bottlenecks as such. For each service put into a template, the required identity and access management or IAM permissions, which some of you all have run into already when logging into your first account. Right? That these will need to go into the template. So that's what the lock and key actually represents. Now, administrators probably don't want to give end users access to all of those permissions. So here comes our identity and access management. Admins can instead create IAM roles within the AWS service catalog so that the templates inherit the correct level of permission necessary to launch the apps. All right, got it? It's the template itself holds the necessary IAM permissions. So the users can use that, and then they have the necessary permissions to launch the apps that they require. So you can see that within the AWS service catalog, there are two distinct user types. You have administrators and you got end users. Catalog administrators can create portfolios and register products. Admins are also responsible for authoring the templates that define how the product should be built and the resources and security controls that need to be applied. Now, end users. End users are the people who need an app deployed to their account. They can browse the AWS service catalog to find the product they need. And then they can launch that template without having to cut a ticket and wait for someone in the IT department to build it for them. This is a time saving, a cost effective measure also. Now, admins get some peace of mind as the end users do not need to have the IAM permission to access all of the AWS services they need in order to launch the resources defined in this AWS template. They only need access to browse and launch the products. Okay. Now, why? And this is important. This is because the AWS service catalog, it assumes a role to launch that template for that particular user. And the role already has the needed IAM permissions. And this is how it works. So what are the benefits we get from this? So with this service catalog, we can control which products and versions of products are available, ensuring compliance with corporate standards. We can also control the configuration of available products and their permissions. A product is what? It's an IT service that you want to make available for deployment. And it consists of one or more resources. Additionally, it provides a single location where organizations can centrally manage catalogs of IT services. So you can control the user IT services by specifying constraints which allow you to restrict the ways that specific AWS resources can be deployed. Now, what does all of this mean? All of this means that end users quite quickly discover, deploy IT services using a self-service portal. When it comes to best practices, you should apply IAM permissions to your products so you can control who can view and modify your products and portfolios. Now, applying the IAM least privilege principle to each product is necessary to avoid unapproved operations. So these permissions have to be set correctly. Then constraints should be set. Now we aren't going to get too deep into this. This is just we are walking through the usage of the and best practices for the AWS service catalog. Now constraints restrict the ways specific AWS resources can be deployed for products. So there are two types of constraints. There are template and launch constraints. Okay, now what is template constraints? Template constraints basically allow us to reuse generic AWS CloudFormation templates and apply restrictions on a per product or a per portfolio basis. Compliance requirements should be embedded over there. Launch constraints obviously allow us to restrict user permissions without impacting the ability to provision products from the catalog. Now, this is a short list of who should use the AWS Service Catalog. It's actually been developed for organizations, IT teams, and managed service providers who need to centralize policies. Okay, so for IT administrators, they can manage AWS resources and services. It provides large organizations like a standard method of provisioning cloud resources for thousands of users. And it's also well suited for small teams where front-end development managers can maintain a standard development and test environment. For example, you need stability in your environments, whether it's testing, development, whatever. And as far as possible, they should be about the same. For developers, you can define a portfolio of development environments, like a certain stack with the approved versions. So that can be used for software development and testing. You can approve or rather define a portfolio for a marketing organization or department. That will include campaign websites, market analysis applications. Okay. So let's summarize what we learned in this short module. It allows administrators to create, manage, and distribute catalogs of products to end users who can then access the products they need in an AWS account. Admins can control who has access to each product, enforcing compliance with business policies. The AWS Service Catalog allows the organization to benefit from increased agility. Why? Because we don't that bottleneck. Because the IT department, otherwise the IT department itself has to create and launch the application and approve them, the requests. So that agility is, that bottleneck is removed. So that's about it for our AWS Service Catalog. So you see how organizations can benefit from this. It's nothing to do with your whatever services you actually provision on AWS, your AWS management console. It's how these organizations can manage service catalogs for thousands of users in a very flexible and agile manner. So I thought that would be a good thing to keep in this, to just have a brief review of how it works. Now let us take a look at our core services. This is what AWS is all about in the end. So this is a little bigger module, as you can understand, because we have to go into this in some kind of detail. So in this module, we are going to look at what we can call the core services of AWS. These are basically the foundational services that are utilized by most customers of AWS to perform like typical computing, storage, and routing actions. Now, there are basically four core services. We'll describe the functionality and the uses for each. First, we'll take a look at Elastic Cloud Compute, which we'll be going into quite a lot of in detail tomorrow. Also called EC2. Each of them have the acronyms, generally with a number. Now you can think of this as as a basic unit of computing. Think of it as a virtual machine where you can run an application. Next, we'll talk about simple storage service, also called S3. This is AWS's famous static file hosting service, which can be used in conjunction with EC2 and also by itself. Relational database service, also called RDS, is an umbrella term actually for several different managed relational databases offered by Amazon. And finally, we talk about Route 53, which is the DNS service that empowers your EC2 instances and S3 buckets to be accessible via URLs. We'll see that. Now, Elastic Cloud Compute was launched by Amazon around 2006. I think it was the main premier solution to solve computing needs. Now, since then, you'll notice it's become the foundational block for most applications utilizing AWS, as well as the basis for many other services. So Amazon has added many features to EC2 over the years. So what can you do with EC2 instances? Like this. Actually, it's a little difficult to answer this question. It's like asking, what can you do with a computer? So in many ways, an instance is basically a computer. So we can use it to run an application, be it a web application or local. You can log into the instance and use it like a remote virtual machine. EC2 instances can have very specific types of software installed on them to do all sorts of tasks. Like remember, we're not only talking about deploying web pages. Anything, any kind of computing, including heavy intensive calculations, that's also anything goes. Nearly any form of computing. So really that's what EC2 is about. Okay, let's take a look a bit at the technical specifics of EC2. Firstly, let's break down the name Elastic Cloud Compute, since the very name, I think, provides some insight, right, into how the service works. Now, cloud compute should make sense based on the last module we've done. EC2 is a service that can be used for computing services like running an application and is located in the cloud. In other words, it's not like under your desk. The elastic term in EC2 is much more interesting. Elastic means the computing service can expand and retract as needed. Okay, now I mentioned this action before when we discussed scalability, but EC2 is very convenient in this respect due to the fact that rules can be set up so the scaling up or down happens automatically without you having to do anything manually. When we look at auto scaling and groups, we look into it with a little bit more detail. Okay. The basic building block of EC2 is an instance. An instance is essentially a virtual server with no dependency on an operating system. Fine. I think, there's a number of different aspects to EC2 instances. So I thought it might be good to just demo this in the console. We won't be going into it in a lot of depth as such, but because we'll be going into it in depth tomorrow, but we can take a look how to actually configure an EC2 instance. Okay. Now there's several options that are actually configurable with each instance. So you need to make decisions with each of these whenever you create an instance with EC2. Now to get to this, you have this drop down over here called services, and here we got all the services imaginable. All right, so we can go and simply click on EC2. And you see over here, you'll have EC2 dashboard. Okay. So this is from here, we can actually see all the instances that are running, our dedicated hosts, our load balancers, our elastic IPs. I did say elastic is one keyword you'll find recurring very frequently. Our security groups, we see later how to do that. The key pairs, which is related to your instances also, right? Okay, so for now, once you come to this page, if you've already logged in, you remember, go to services, click on EC2, and that's it. You'll come to a launcher instance. Just click on that. Now, the first is the image, AMI. Now we'll be going into this in more detail because we have a lot of stuff to do with EC2. But let's just take a look what we have to do to actually get it up and running. Now this image is the fundamental code that will be running on an instance. It's not your application code at all. You have also a number of options you can choose from. We will be going with this, and remember this, Amazon Linux 2 AMI. Okay. For most of us, it'll be a x86, I would guess, but you have many. You got Windows, for instance, you got SUSE Linux, Debian, quite a few. But for our purposes, you got Red Hat right at the bottom. For this course, we will be taking advantage of this free offering, Amazon Linux 2 AMI. Okay. This is very good, very popular, very much in use also on the free tier. Okay. So as you see, many different options you got. The top is Amazon's. This is Amazon's flavor of Linux, if right, which you might have guessed. Amazon's own flavor Linux, then you've got Red Hat, you got SUSE Linux, and you must be having Windows. Ubuntu must be around here somewhere. Here's Ubuntu. So Microsoft Windows is also available. And you can see that there are different versions of everything mentioned easily available. Of course, but this is what we will work with. So let us, after our break, we have a break now for 15 minutes. I'll see you all at 3:30 in 15 minutes, whatever. And we'll see how to set up an EC2 instance when you all return. Okay, so go
Okay.
ahead, please.
Okay, sir.
Thank you. Yes, please go ahead.
Dear participants, please take 15 minutes break. Again, we will join at 3:30 p.m. in the same link.
Okay, so let us continue. Now we were on to, if you remember, we went to services and then we went to EC2, and that will take you to your dashboard. From there, we chose launch instance. So we'll be going through this. We'll do a deep dive into it tomorrow. But for today, I want to show you the screens, actually. So the first thing is choosing an Amazon machine image. And for us, frankly speaking, it's not like we have that much choice, right? Considering we're on the free tier, but this is the best that I know of. The first one, Amazon Linux 2. So we'll use that tomorrow also. Okay, now as we talked about, that is actually Amazon's own flavor. Then you got various. You got Linux, you got Red Hat, Ubuntu, all that. Just something we need to talk about. An image is actually that it's nothing that you do. It's actually the fundamental code that will be running on an instance. That's what we have actually done. Okay, it's not your application code. That's different. Okay. So we can see that an image is a combination of an operating system and then some applications pre-installed. Typically things like Java or Python or the AWS CLI tools. The AWS CLI tools, Amazon has given developers a number of ways in which they can connect to AWS. Not only through the web, you can have CLI tools which are command line tools. So you can use that also to connect. Now, what does Amazon do? Just to be clear, it provides, it manages, and it updates a selection of the images that are available. Now, image updates are important, like to patch security vulnerabilities that might be found throughout the year. And having Amazon and their team, security team handles that responsibility, provides, peace of mind. Just one thing to keep in mind, a caveat. Amazon won't be updating that instances software. They just update the available image. Now, for instance, if you need to update your instance for security patches, you need to either manually make the updates or create a new instance and migrate any application code. So what the Amazon provided images are just the beginning. So if you go back to our screen and over here we see AWS Marketplace. Take a look at this. Now, what this allows us to do, it gives you the ability to provide images that you can install easily. So some images are full applications provided by vendors that you can use off the shelf. Some examples, scroll through it and take a look. Some like enterprise firewalls, security applications, content management systems. You can see it's quite a lot over here. There's stuff for infrastructure, DevOps, machine learning, Internet of Things. All right. You got deep security from Trend, for instance. There's even a subscription model in place for images that vendors can utilize to charge users for their software. That is the AWS marketplace. Oh, right here. Okay. Now, open source, the community also, they can also upload images like for open source software. What I'm talking about is like for MongoDB, for instance, or the mean stack related stuff. So while using some type of open source image, you only need to pay for the hardware that the image is running on. So quite versatile, actually. So after this, so if we select this, then we'll come to choosing an instance type, right? So that's your next decision. What is this? This is essentially the specs for your instance, like the number of CPUs, the amount of RAM, and the network performance. So with these three options are instance storage, as you can see. Amazon has created actually instance types and families. Here's a network performance. The memory is over here. And then of course our free tier eligibility options that we have over here. So families, actually, this is also pre-selected. Families actually provide an easy profile to help you decide the right type for your use case. So you can see that this first one is T2. This is like a set of configured options that are available. So suppose like you're running a file server. You might want one from maybe the storage optimized family. For instance. Or if you're doing some machine learning, then there's something you'll see where whatever is optimized for computations, that would be best suited to your needs. If you click this, you need to have some understanding of like the available types. Let's look at compute optimized, for instance. Here. This would be perfect for if you are doing machine learning. Okay. How about if you're simply running a file server, you would look for storage optimized. And these would be the instances that you would be interested in. So it's your call in the end. So go through all of this just to familiarize yourself with, the different instance types that are available. And then of course, there are different there are types like small, medium, large, extra large, etc. As you can see over here. Now, to give you a concrete example of what I'm describing, let's compare the large instances and the general purpose, the memory optimized and the compute optimized. There are other selections available you've seen, but let's take a look at this. You understand this, then the others will make sense as well. Because these are the three of the most popular categories, actually, or rather types. So the general purpose large instance provides a balance of CPU, memory, and network performance. So we sort of look at it as a control group. Think of it that way. Now the memory optimized large instance has the same number of CPUs as the general instance, but twice the memory. On the other hand, the compute optimized instance provides the same number of CPUs as the general, but cuts the memory in half. All right. So you might think that makes compute optimize the less of these. But with a difference in features, remember it's all comes down to pricing in the end. A difference in features boils down to a difference in price. And the compute optimized family instances are actually the cheapest of all of these. So as you can imagine, increasing the type from large to extra large or down to medium will give you more or less each feature at an equivalent ratio. So for your application, the point of all this is you must consider the best instance type that you need. So don't overutilize. Don't take something that exceeds what capacity your application needs, or of course, underutilize. There shouldn't be underutilization or overutilization. So this can not only help you perform better, but it can also save you a lot of money. Okay, so once the image and instance type, we go back to our screen over here. Once that has, let's decided, then we can configure our instance details. So click on that and we'll come to this. Step 3. So we have a page of instance details that relate to where's our security roles. And there's a lot of further fine-grained configuration, as you can see. Okay. So many of these are important, but for now, we'll just talk about the number instances field. So over here, you can assign a number to replicate with the same image and type. Okay. So what does AWS do? AWS will create an auto scaling group. I think we had mentioned this earlier, maybe in the last module. It will create an auto scaling group that will increase or decrease the number of instances according to rules that you set for yourself. So once the auto scaling group has been created, you can modify it further. That is there. Now, if you're working with a third-party image or one you made yourself, this is the perfect way to set up scaling. Okay. Now, if you're curious actually as to how to have an application that you've installed on an instance configured to auto scale, this is actually easiest to accomplish with the application service called Elastic Beanstalk. Now there'll be more on that later, but just keep it in mind for scaling Elastic, and you can see just the very name itself, Elastic Beanstalk. That is how you can configure your instance to auto scale. Right? So use EB for scaling applications and use EC2 for scaling EMIs. So back to our screen. The next step is to add storage. Here. Now, storage is actually, you see this term, you can add attach additional EBS volumes. Now, don't get worried about all the acronyms that you'll come across. There's a lot of acronyms and terminology. It'll become second nature to you after you worked on it for a while. EBS is actually what Amazon uses to conceptualize storage. It means elastic block storage. Like I said, elastic is a term that a word that you'll come across frequently with AWS. So this is essentially, it's a storage service that makes it easy to reason about and calculate charges for storage. So on all these volumes that you see over here, they live independently from your EC2 instances. Keep that in mind. All right. You can add volumes, of course. This is our free tier eligibility. But the takeaway from here is that the volume, because actually it's data, it's your data. It could be a company's data. And data, as we all very well know, is a company's asset. So the volumes live independently from our EC2 instances. They can be retained or deleted when the EC2 instance is terminated. That is your preference, how you set up things. Now, as a note, elastic block storage is not the same as simple storage service, which we're going to do next. Elastic block storage is specifically for using with EC2. That is the EBS that is referred to on the screens. Whereas S3 is for both storing and serving up independent files. Just as a note. Okay. Now in this menu, we can actually adjust the root volume size for the elastic block storage volumes which are attached to this EC2 instance. Then we have tags. We'll actually skip over tags. These tags actually meta values you can add to your instance for your own purposes. Okay, let's skip over it. It's something that you do for your purposes. Key value pairs, as you can see. Now we come to the security group configuration section. You can create a new security group. You can select an existing security group. Okay. Now, if you remember from the last module, security groups can be thought of as little firewalls, right? You remember that slide with the bricks and the flames coming out? Those are our security groups. So they're little firewalls configured on a per instance basis. So put very simply, a security group controls which IPs your instance can talk to and which IPs can talk to it. Matter of fact, if you deploy an application on Heroku, you can configure access. You can only allow your local host, for instance, to talk to your application or accept requests from it. So Heroku has that feature also. Now, for instance, it's not a good idea talking about security because this is very important, especially on the cloud. It's not a good idea to leave your instances open to SSH sessions from anywhere. So it might be good to allow only incoming SSH sessions from your current IP address, like my machine or your machine. You could also allow your instances to talk to each other, or say a database, or accept incoming requests on port 8080. That you could do. So there are many different ways you can use security groups, and once they're created, here you can edit them and you can add more rules later. So the final step is to actually you can review all your instance settings. Okay, you can see what it says over here on my screen. Your instances may be accessible for any IP address. So we recommend that you update your security group rules to allow access from known groups only. So here's our AMI, here's our instance type. Our security group was whatever default. We're not going much into it. This is just to our instance details, our storage. Tags are non-existent. Okay. So that's how we create an EC2 instance. So now that we've covered the basic configuration options, let's take a few moments to talk about the pricing structure for EC2. Now, any actual numbers will probably likely change when you go and check yourself, but just to give you an idea, right? Maybe the structure will be the same, who knows? Now, Amazon charges for EC2 instances by the hour, and the amount per hour, obviously, it differs based on the image type and the instance that you've selected. Like this. Some images like Windows image will cost more than a Linux image simply because the image software must be licensed and paid for by Amazon. All right, let's look at some examples. Let's look at the pricing of a large memory optimized instance running Amazon's Linux image. So the per hour rate is 12.6 cents, which gives it a daily rate of around $3 a day. This is the Amazon Linux 2, the AMI that I selected in this session, and which we will be using. It's the best option. Anyway, so you only pay for what you use. So you can start and stop the instance whenever you want and only pay for the time it was alive. Right. So $4 a day might be a little steep in your case. So let's look at a little more basic offering. This is a general purpose T2 micro instance. Also, the Amazon machine image is Amazon Linux 2 or Linux 2. The instance type comes with one CPU, this 1 GB RAM, and costs 1.3 cents per hour, which adds up to around 31 cents a day. So now we're talking. For a month, that's around $10, which is fairly reasonable. So Amazon has many, many options for pricing. Okay. We are actually talking about on-demand pricing over here. This is on-demand pricing. So here's the other models. Like you have reserved instance and spot instance pricing that both offer lower prices than on-demand pricing. It can get a little confusing, right? So that's why that AWS calculator is very useful. And then of course we have the free tier of usage for many services. So have recourse to the AWS calculator just to figure out what is what cases like this, but you can see how pricing differs, the pricing types also. Last I know it, this is how the EC2 free offering is. So you got like 750 hours of T2 micro computing per month for an entire year. That's good. So anyway, there should be enough free usage for all of us to get our feet wet with the service. All right, one last note with pricing in regards to EC2 is the elastic block storage that your EC2 instances use has a separate charge associated with it. 10 months, sorry, 10 cents per month per gigabyte for general purpose SSD volumes. Now, currently, last I checked, there are no additional fees for auto scaling, but an additional load balancer or elastic IP do cost extra. But you get, okay. It's 0.0225 USD an hour. So all these costs should also be kept in mind when you're calculating your total cost for your EC2 usage. You must also figure in your additional pricing. So you can advise for yourself, or when you advise your clients, you can advise them appropriately. Now there's plenty more to EC2 instances than what we covered that we will do a deep dive tomorrow. But this, I hope it gives you a nice overview of how EC2 is presented and what you can actually do with the service. So EC2 also, think of it this way, it's actually used under the covers for other services like the relational database service, which we're going to cover in this module. So anyway, it's a good idea to become comfortable with managing and configuring these instances because this, after all, is a core service. Next, we come to our simple storage service. This is also called S3. And that's a tongue twister, right? Simple storage service. It's a service, as we talked about before, that actually stores files. So although you can host files for end users, it's not all that is used for. It's a sort of, how can I put it? A catch-all service. You understand? It's used by other services in AWS like CloudWatch and Elastic Beanstalk, for instance. And I wanted to show you this. Now actually is widely used throughout AWS as a place to simply store files. Now it can be used for any type of file, and the only limitation is a maximum file size of 5 terabytes. And that's not a mistake. The maximum object size is actually 5 TB. Now, according to the AWS documentation, the largest file size that you can upload in a single put operation is 5 GB, but there are other methods you can use to upload a larger object, but you'll need separate operations. But this is the largest size. I thought you might like to know. So what is our structure of S3? Buckets. Buckets are the foundational structure of S3. So a bucket is your root resource to which you can add, delete, or modify objects. Now, there are all sorts of configuration options that you can set on buckets, like permissions, like hosting options and logging. And buckets can be configured to trigger events when changes happen. Now, this is huge. I mean, I mean, seriously, a nice feature. It's like having all your own listers configured, right? So they can preserve old versions of other objects. They can automatically replicate objects across regions also. Now, once created, buckets are assigned URLs like this. Okay. Now, to which you can access the objects contained within them. So you can see here's our bucket region, a bucket name, and I'm storing an image. That's the object path. So this actually points to the image in my bucket designated by my bucket region. Take a look at this, for instance. This is a screenshot from our console. So yeah. Now when the permissions for objects modified to allow anonymous access, then we can host static files on for websites. So you can take a look at this. It's just a PNG, it's an image, a static file. And see the permissions is publicly accessible at the moment. So in this case, then we can host static files. So S3 is very often used for that. Now there's a lot of options that Amazon has added to S3 to make it extremely flexible and useful in a variety of situations. So it makes it simple, for instance, for hosting a static website. Here's your URL. Can you see? When you configure your bucket as a static website, this website is available at the AWS region-specific website endpoint of the bucket. And here's our website URL. Then, within the bucket configuration options, there's the ability to enable static website hosting for the given bucket, as you can see, right? We've got enable over here also at the top. Now you still have object level permissions, which will give access to anonymous or authenticated users. But the bucket itself will respond to requests and be enabled to interact with around 53 URLs. All right. So this is a quick and easy way to get a static website up with very minimal cost. Okay. Now, if hosting a site like this or even just assets for a website like images sounds just like a use case you might be interested in, you may be wondering how to solve the latency problem we talked about in the last module. Okay. Now with S3, you can automatically replicate files to other regions, but AWS provides a better solution. Now by using another service from Amazon called CloudFront, you can cache your content, sometimes called edging your content at locations around the world. We'll come to CloudFront later. Now, let's talk again about how much this is going to cost us. S3 is price based on three aspects: the number of data, amount of data stored, the number of requests for objects made, and the amount of data actually transferred. So prices are different per region and base costs go cheaper as volumes go up. That is to be expected. Here's a pricing example for the first year of each in the first year in the Oregon region. Okay. And you can go to this website down below, S3 pricing, and you can check for yourself the current pricing. Now, note that these prices are per bucket. That's like a unit of storage. So AWS charges 2.3 cents per gigabyte of data stored, which is pretty reasonable. Requests are priced differently based on the type of request. But put requests are basically, let's see, this is 5, that's half a cent per 1,000 requests. Half a cent per 1,000 requests. Okay, that's okay. And for data transferred, the first gigabyte per month is free and then 9 cents per gigabyte up to 10 terabyte. So overall, S3 is actually pretty reasonably priced for storage and has a low barrier of entry, not to mention that there's a free tier giving you 5 GB of storage and some free request and data transfer for the first year, which is what we have subscribed for. Next, let's take a look at relational database service, which is all to do with our RDBMS. So we call this RDS. It's a collection of AWS services for managing relational databases. Now we call the database managed because AWS it takes care of all the backups, all the software updates, and the infrastructure for the database. So that's of course to be expected. By now you would have guessed. At AWS will handle it all the configuration, the replicas, read replicas, backups, redundancy, the software patches that have to be put will all be handled, right? This is just a basic comparison of the database on EC2 versus RDBS, Relational Database Service. Okay. Now, currently, Amazon offers MySQL, Postgre. These are options, actually. Postgres SQL, SQL Server, MariaDB, Oracle, Amazon's own Aurora database through RDS. Now, each carries a different price and different configuration and connection options. That is there. Now, this RDS databases run on EC2 instances. So when you're picking a database, sorry, when you're picking a database type, you should also pick the type of EC2 instance that it will be running on. All right, why? Because with this, you can decide basically for yourself what type of performance your database will need in response to the load it will be under. Next, if you want to use a relational database in AWS, it's recommended to actually find an option in RDS. Okay, actually the reason being that Amazon will not only manage, but it'll also guarantee the stability of the database. Often, you know, the crucial part of any software infrastructure. So that's a huge benefit. Now, because AWS is managing the database, you can quickly do things like take snapshots of your data or increase the size of the EC2 instance being used to back up the database. Now, doing either one of these actions with your own database would be a lot more difficult and dangerous. Security. Now, security, once again, is often the most important aspect of any database, as we all very well know. Now, we all heard the stories like about enterprise companies with databases completely open to the outside world. So that's not the route to go. So let's talk about that for a minute. Now, with RDS, access is controlled via these trusty security groups that you saw on our configuration screens, right? So a security group is absolutely necessary. Now, once again, by configuring the security group for our instantiated RDS database, we can allow our applications access to the database but block other connections. Well, that's the job of it. We can also configure a way for like BI tools to connect so that users can query the database. That is possible. And once again, we come to pricing. Now, RDS pricing depends on the type of database you are using, as well as the region it's created in. And since the base resource that these databases are being installed on are some EC2 instances, the price is higher if you're using a larger instance type. Here's an example. We got a MySQL database. This is actually running on a standard extra large instance. It's got 4 CPUs, 16 GB of memory. If you check that table against it, you'll see the same thing. So 4 CPUs, 16 GB and high network performance. We're looking at about 35 cents an hour. That's around 850 a day. So that's a little high. And that to MySQL, not Oracle also. Now this extra large instance is going to be pretty awesome. You might not need something that production ready. There are definitely instances that you can get down to 1 cent an hour. Just 1 cent. Now also, that's what I said, that MySQL in any case open source. So why is it like pretty high? It's a little steep. Since MySQL is open source and there's no license needed, you can expect that other database types like SQL Server or Oracle will cost a lot more per hour. And finally, if we're interested in using something in AWS that isn't a relational database, and this is at the forefront of software development nowadays, as we all well know, we have some options. So we got like a NoSQL or a document-based database. So DynamoDB, for instance, is actually a NoSQL database. It's an Amazon offering. Okay. And I think lastly, we will look at routing. And routing, as you know, is crucial for any web application. Whether it's developed with, you're hosting it in Amazon or whether you're developing it with Angular or React, routing is very necessary. So Route 53 is Amazon's service for DNS management, both inside and outside of AWS. Basically, it allows you to easily configure domain names to resolve to internal AWS services. So you can use domain names that you already own, or you can register new ones through AWS. DNS, as we all know, stands for domain name system. So the purpose is to translate a human readable URL into an IP address so that two computers can connect. Now, EC2 instances can be configured with public IP addresses. But certain Amazon resources like S3 buckets are a little more complicated. Even load balancers, they're a little more complicated. They don't have static visible IP addresses. So a DNS system is necessary in these situations. So that's where Route 53 actually comes into the picture. What it does is something like this screen here. It allows you to set up URL resolution to AWS resources directly. So it bypasses any need for you to see an IP. Of course, behind the scenes, IP resolution is happening. That is true. But Route 53 conveniently it abstracts this away. So it's as if you have direct mapping from a URL to a resource on Amazon. Now, although Route 53 is actually very straightforward, is actually kind of basic, we are talking about it along with the other core services because it's the best way to let others interact with your application or other AWS services. So the takeaway is that Route 53 is how you make URLs resolve to AWS services. How does it work? Something like this. This is from a management console. We've gone, every service actually in Amazon has its own dashboard. Okay. So first we have to, realistically, we have to set up a hosted zone. So a hosted zone is basically like a root domain name, like example.com or google.com, like that. Now using a hosted zone, you can use Route 53 to set up subdomains like www.example.com or mail.example.com, and you can configure them to route to AWS resources. Can you see? At the bottom of the screen, you got record name, you got the routing, and this is where you actually route it to. Fine. So it's actually very simple, but it's very necessary. That's why it's included as a core service. You can create record sets like A records, for instance, as you can see. You can create something called C name records and MX records. For the, don't worry about it if it's a little abstract right now. Once we actually get into it and we configure and we work through a few examples on a console, it'll fall into place. So all these subdomains, we actually can create record sets. So you can see it's pretty involved, our console. Okay, and as usual, we should take a look at what our pricing is. So that's fairly straightforward. It costs 50 cents a month for each hosted zone, then 40 cents per million queries. And any DNS entries that you add in a hosted zone are basically free. They don't change the cost. All right, so that's pretty much it for the breakdown of Route 53 pricing. There's a few more features that Route 53 provides, and one of the most useful that I know of is actually the health check service. So this allows you to set up regular checks for a given URL path. So health checks will send you alerts based on different rules. For instance, if the URL request gets a response of 503 or 404, you know, it'll give, you can do a health check. It's up to you what kind of rules you want in place. Now, this is a very essential tool if you have a customer facing web application, and it only costs 50 cents a month. So it's not hard to actually justify the value for something like this. All right. So we've wrapped up the 4 core services of AWS. So after this, I hope we all have a better understanding of uh, AWS as a whole. Now, these 4 services cover a lot of the essential functionality of AWS. It'd be very surprising if anyone's using AWS and not using at least one of them. Now, before we let's just recap actually what we've gone through, what we've learned. First, we looked at Elastic Cloud Compute, shortened to EC2, which is the computing platform on AWS. And by creating instances and selecting images as we did when we went through the screens on our console, we are able to run third-party applications or our own code on a scalable and affordable virtual machine in the cloud. The next we covered simple storage service, also called S3, which is Amazon's cloud storage service. And the uses are endless for it. So with very low bucket cost and sub-second responses, it's a great place to store anything from static assets to file uploads. Third service we covered was a relational database service, or RDS, which enabled us to select from several Amazon managed hosted database types. Now, as we discussed, the benefits to using a managed solution like this is in regards to security, resiliency, and convenience because it's managed. So that's a no-brainer. And finally, we took a look at Route 53, which is Amazon's solution for DNS management. So Route 53 is basically how we expose our AWS resources and instances to users, and it interacts easily with other AWS services. Now, I had mentioned extended database. Those are core services. I had mentioned extended database services, but we never covered it today because we will be doing a deep dive into it during the week. In any case, but there's no harm in just taking a brief look at it. So for this, these services aren't core services, but they augment, or they're supposed to be used in conjunction with the core services. Something like this. For instance, we'll be looking at EC2, and then we'll be looking at, but we'll be looking at it, we'll also be deploying a server, for instance, a web server. All right. And then we see how it works with AWS Lambda, which is AWS Lambda, for instance, is not a core service, but is very popular and it's an extended service, you can think. Okay. These are just a few. EB is Elastic Beanstalk. Now, what is it? It's an application service which will take your application which you have written in Java, Python, Node, Ruby, or any language and get it running on an EC2 instance. Then Lambda. This is a service that actually allows you to run simple functions and get the result. We all know Lambda functions from Java, from JavaScript. In JavaScript, of course, Lambda Some programming languages call them lambda operators. JavaScript calls it arrow functions, but basically the same functionality, right? Anonymous functions, shorthand syntax, concise, anonymous functions. So in that sense, that's lambda, loosely speaking. So it will allow us to run simple functions and return the results. Now it can be invoked from many different sources and written in many different languages. DynamoDB, we saw in the previous slide, it's a managed database solution offered by Amazon that is a little different than those in our relational database service. It's actually a managed NoSQL document database service. Now it's managed by Amazon, so it's got those benefits besides overrolling your own service. Now, virtual private cloud, if you can see this thing is hiding it over here. VPC is a virtual private cloud, is a service enabling you to control access and secure your instances and services in AWS. Now, this is used by almost every service in AWS, and it's the best way to ensure that your data and application is safe. CloudFront, what we've been come across a couple of times in this today's sessions, it's a CDN service from AWS. It enables you to edge your files so that users can get to them super fast. Now it can be used in conjunction with S3 and mentioned previously, or with a web application behind a load balancer. CloudWatch, by the very name, as it suggests, it's a logging and alarm service used with almost every AWS service available. So you can set up alarms to let you know when instances are down, or EC2 CPU capacity is high, or when S3 charges reach a threshold, like, those are some examples. So there's any number of things you can do with CloudWatch. Okay. Once we covered all these, or most, at least these extended services in this training, we have done actually mostly all the major services in AWS. And we cannot cover all. AWS has over 165 to what I remember, available services, the last I know of. So we're actually looking at the tip of the iceberg. Still, even then, we are covering the most commonly used services. So you'll have a solid understanding of what AWS has to offer. And this will bring us to the end of this module. I know it's a lot to take in one shot, right? But once as I mentioned before, and I'm sure you'll have the patience to get through it, you need, for AWS especially, you need a solid conceptual understanding, and your theoretical foundation has to be there before we can start, setting up instances, configuring services, and doing all the other rest of the stuff. Because what is the point of configuring and setting up an instance when you don't even know what it actually does or what its main uses are? Why do I want an EC2? Why do I want an RDS? Why can't I go with SS3 and all these kind of things? So that conceptual understanding, now that we have that in place, we can move on and go on to the more practical aspects of this training. Now, to end up, let us take a look at AIM, which is Amazon's Identity and Access Management System. So this is a relatively short module. All right. So there's a this is actually a very short module. We have Amazon's web service, identity and access management, as you see. Like for instance, when you go to login, when we were logging in, for instance, we had that option, and then I advise some of y'all don't click on the IAM. Select the root user because that is unrestricted access. It's only when you have that, when you're logged in as a root user, that you can uh, actually you know that you can create different roles and different users with the appropriate permissions. So until then, don't touch it. And now Amazon has set up this identity and access management. What we are basically talking about is, how do you say, it's authentication and authorization. That's it. So what it actually does is it enables you to manage access to AWS like services as resources securely. Resources as services are the core. That's the basic thing that it is. Now using IAM, you can create and manage AWS users and groups. And we actually basically we use permissions to allow and deny their access to AWS resources. You can see this over here. We haven't come up to it as yes, that's the AWS CLI, just like your command prompt. So your AW below that is AWS SDK. Right? AWS, like you know of the Java SDK, software development kit. So Amazon also provides you these its SDKs. So that's for developers. Amazon is for developers. AWS is for developers. And a management console you'll have seen already. This is what everyone uses. You have an Amazon account. This is what you have access to. So your authentication is just, this is permissions that you have access to, the ability to actually manage users and groups. Permissions to allow or deny the access to AWS resources. Now, IAM is a feature of your AWS account and is offered at no actually additional charge whatsoever. So this is what it actually looks like. These IAM policies are actually JSON documents which are used to describe permissions within AWS. And JSON documents, you know, the format is actually replaced XML more or less, right? So these JSON is a nice way to represent objects also. So for certain users, according to their name, you can give them access. They describe access within or permissions within AWS. So a very lightweight way also, a nice convenient way to describe permissions which you use with JSON documents. Something like this. This is a sample policy. And you can see it's a normal JSON document. Here's your array. Take the action, for instance, it's an array has got like 2 attributes, S3. You can delete the object. You can get, that's the tasks which are allowed. And here's Sid. He is authorized, right? If you look at IP address, what conditions need to be met? This is the source IP from which the request is actually coming from. what resources can these to which authorized tasks you can perform authorized tasks on these resources, and what are they? You can do billing and marketing, and you can do billing and sales. So very lightweight, very easy to put it together. Okay. So the first thing you have you put it all together, you need to form a group. Your IAM policy will apply to that group. Okay. And as an individual user, that policy applies to you. So it's necessary to actually formulate your groups, and then the appropriate permissions can be granted. So IAM users and application services can assume IAM roles. Okay. They use an IAM policy, as we saw before, a JSON document for permissions. Let's take a look at one use case. Here's an Amazon EC2 instance, and here's a Amazon S3 bucket. Now, this is something we have this kind of role over here, all right, with a certain set of permissions. Some existent, some are non-existent. Okay, so what this is that it enables actually very fine-grained access control to AWS service APIs and resources. Okay, it also enables specific conditions which hard to believe, but also time of day. They can control how a user can use AWS, the originating IP address, whether they are using SSL, and how they have authenticated, all this kind of stuff. So once that role is handed, okay, once that role is handed to someone in the organization, they can assume the control of that Amazon EC2 instance and this. Fine. Here's a restricted policy for one particular user, and you get access, but you can also, like I said, you can have very fine-grained access control to your AWS resources, very fine-grained. So the first thing is that when an IAM admin, like for instance, a policy is actually created, it needs to be assigned to a particular role. So policies and roles, they go hand in hand over here. Once you have that, once the policy is assigned to a particular role, it can be assumed by a user. So for instance, say you have an IAM admin policy, you will need to create a role, and that it will be assigned to that. Now this is probably not very new to you, because this is authentication and authorization. These mechanisms are in place in different frameworks also. So once that role the policy has been assigned to a particular role, and that role has been assumed by a particular user, then you can think of it as certain policies, he has the admin access to that automatically. Okay. So why should you use the identity and access management system in AWS? Firstly, to manage the IAM users and the access. Manage IAM roles and their permissions, because roles have a set of permissions attached to them via the policies. You can create a set of policies and then assign it to a role. And also, the one last thing is that you can assume a role over here, and then it can also be, you can revert back to the previous role. So you can revert back to a previous user after your work is done, and those privileges can be unassigned. That's what can be done very easily. All right, and manage federated users and their permissions. So you can group together within an organization. You can make like federations for users and their permissions. Okay, so you have it, organization wide authentication mechanism in place. So that is your identity and access management in Amazon Web Services. So thank you very much, and that concludes day one. Tomorrow, I think you'll all have the syllabus that was sent to me. So tomorrow we'll be working on, we'll do a deep dive into EC2, what we just had a little introduction to today, and along with AWS Lambda, setting up a web server. So it'll be a lot more practical than it has been. So thank you, everyone, and I will see you all tomorrow.
Thank you, sir. Thank you so much.
Thank you.
Dear participants, again we will meet tomorrow at 9:15 sharp. All of you can join this meeting using the same link.